1 second. Welcome everybody to the presentation. I'll start off with an introduction about us. So my name is Parul. I am the founder of the Oxbridge formula. I studied maths at Oxford and I graduated with a first class degree, then became a teacher. I've been a teacher, well, I taught for 10 years and we founded the Oxbridge formula to help students kind of navigate the process of kind of doing really well with these admissions tests and the Oxbridge process for STEM subjects. I then have Chris, give everyone a wave. Chris is our lead tutor here at the Oxbridge formula, our founding tutor. He has a first class master's degree, so undergrad and master's degree in maths and philosophy from Merton College, Oxford. He's been our tutor here, as I said, since the beginning, very good at explaining kind of complicated concepts, which you'll see later on today. And yeah, then we have Agnideepa. Give everyone a wave, please. So Agnideepa is a third year, or just finished her third year, I should say, in fact, literally yesterday, student studying computer science at Cambridge. Did you want to add something?
No, that's good.
Okay, yeah. And she can't remember what college you're at.
I'm at Churchill College, Cambridge.
Okay, perfect. Yeah, so she will be sticking around, giving her input, and then at the end, her and Sebastian, who we don't have a picture of right now, but he's going to be joining later on. He is a maths and computer science student at Oxford. They'll be sticking around to answer all your questions. If you do have questions, guys, there's just I want to make you aware there are two things. There's a chat and then there's the Q&A. It will be much better if you put any of your Q&A questions in the Q&A box rather than the chat box, because then we will have them all at the end, whereas if you put them in the chat, there'll be other comments in between and we won't be able to find your questions again. So just to keep those two things separate. All right, so let's get started. What we're going to be covering today. Oh yeah, before we move on, here are just a few examples of people who studied with us at the Oxbridge formula and were successful at getting their maths or computer science places at Oxford. And as part of this presentation, we'll also just be touching on some of the preparation options that we have available for you for maths and computer science courses at Oxbridge. So what are we going to be talking about? Well, first of all, we'll talk about what the MAT, CTMUA and CSAT are and when they're going to be taken. How are they used by Oxford and Cambridge specifically? How do they differ in question style from A-level, and how do they differ from each other as well? Then we're moving on to like problem solving skills. So we have our own proprietary kind of problem solving methodology called PROF. We'll be looking at that in a bit more detail. It's how to dissect a question. The number one thing people tell us is when I look at the solution of a question, it kind of makes sense, but I never would have thought to use that approach myself. And so this PROF methodology that we've developed or designed helps you to figure out the approach to take through practice. But yeah, we'll talk more about that later. Then we are also going to talk about Dr. A. Now, Dr. A is part of the P in PROF, but it's a technique for problem planning when you have specifically abstract questions. And for the computer scientists out there, your questions are a lot more abstract, as well as the question 5 in the MAT. We'll then touch upon exam technique, preparing, well, what you need to do to prepare to sit the various tests. And yeah, that's it. So what are the MAT, CTMUA and CSAT? Now, hopefully you already know this, but in case you don't, the MAT is the maths admissions test and it's for Oxford, Imperial and other universities. Like Warwick, if you take the MAT, you get like a reduced offer, for example, and it's used for maths and computer science courses at Oxford, maths courses at Imperial and joint courses. Then the CTMUA is the computer science test for Cambridge. It is a pre-interview test, so it's taken in November. By the way, all of the MAT and the CTMUA are taken in November, and CSAT is taken at interview in December. Now, the CTMUA has another name as well. It's also the TMUA, but Cambridge, when they adopted it, put a C for Cambridge in front of it. The TMUA is also used for maths applicants at Warwick, Durham, LSC, and others. So then we have the CSAT. The CSAT is a test that used to be the admissions test for computer science applicants. It's a test that you sit at interview, and the reason that they kind of switched from the CSAT to the CTMUA a few years ago was that there were just so many applicants. It's a very popular course. There's so many applicants that they needed a way to whittle down the candidates before interview, if that makes sense. So CSAT is still used, but only at a few colleges, which are Gonville and Keys, Peterhouse, Queen's, Robinson, and Trinity. Having said that, even if you're not applying to one of those colleges, it's still a really useful test to kind of prepare for, because the kind of questions you could get asked in your computer science interview are actually really similar to the CSAT questions. So it's a really good source of preparation. I highly recommend all computer scientists do those papers. Okay, so let's go into everything in a bit more detail quite quickly.
I just wanted to add, we had a few people asking about STEP, so maybe we should mention.
Yeah. So this presentation isn't specifically going to cover STEP. However, we did a separate STEP webinar earlier. STEP is used for Imperial College Computer Science. You don't technically, I don't believe you need it for maths. You don't need it for maths at Oxford. Do you need it for computer science at Cambridge? Do you know of any colleges Agni Deepa that ask for it?
I don't think so. I think it's specifically used for maths at Cambridge.
Maths at Cambridge, yeah. But Imperial College does use STEP for their computer science offers. And in terms of, do we offer preparation for it? Yes, we do. So when you look at the preparation options we talk about today, STEP is included within those, okay? So we've already discussed when these tests take place. How long are they? Well, the MAT and the CTMUA are 2.5 hours each. The MAT is split up, being 1 hour for the multiple choice section and 1.5 hours for the long questions. The CTMUA is 1 hour 15 for both of the sections, section 1 and section 2, and we'll discuss the difference between those in just a second. And the CSAT has 2 parts as well, roughly 30 minutes and 90 minutes for those. And how many questions do you have to do here? So in 2.5 hours, well, in that 1 hour, you've got to do 10 multiple choice questions, which means it's 6 minutes per multiple choice question. And then you have 1.5 hours for 4 out of 6 questions. And that's important. You do get a choice. We'll look at that in just a second, depending on what course you're applying for, which roughly equates to 22.5 minutes or 20 minutes with a bit of checking time at the end. And then in the CTMUA, they're all multiple choice, and you have 20 in section 1 and 20 in section 2, amounting to 3.75 minutes per question. And then you have the CSAT. Well, you've got 2 sections, and part 1 is kind of easier, shorter questions. Part 2 is longer questions. Neither of them are multiple choice. You have to answer them fully. And in the first one, you choose 5 out of the 8 questions. And in the second section, you choose 5 out of 12, which amounts to 6 minutes per question or 18 minutes per question in parts 1 and 2. None of the tests, including STEP, allow you to have a calculator or a formula booklet. So you do need to be very familiar with all the formulas that you're expected to know, and your trig values and all of that kind of thing is really, really, really important to know off by heart. So let's move on to the next page. What is the MAT all about? You're going to be tested on mostly year 12 A-level maths, but there are a few exceptions, and a notable exception is geometric series, which is now technically in the second year of A-level, although if you do further maths, it's likely you will have covered that already. Then we have, as we said already, which long questions you do in the MAT depends on which degree that you're applying for. And we're going to look at that in just on the next slide. Many questions, though, are quite independent of what you study at A-level, especially the computer science questions. And there are some concepts which are slightly more undergraduate level that you could be asked. So combinatorics, sets, axioms, recursion, and limits are those key topics. The style of question is really different from A-level. So it does require ingenuity, intuition, and a deep understanding. And why is this the case? Well, these are the kind of skills or attributes of somebody who would be a good mathematician or computer science at university. So I think what they say is A-level maths or further maths don't really select the best candidates because it doesn't mirror the level of thinking you're going to need in a maths or computer science degree. And that's why these admissions tests are so popular for those subjects. In the mat, you will be required to write down proofs. And what they like to do a lot, and we'll see that later on today, is ask you to explain things in words. And justifications and explanations are really good. And it's something that students often struggle with. So we'll be looking at that a bit more today. And these tests have been used, the mat has been used for many years. I think it's 2007. And even before that, it used to be kind of used in a non-official format. So what does that tell us? It means that this test clearly correlates with success in your degree, and that therefore it's a good predictor of who's going to do well in that degree. So let's have a look at the mat questions. If you do maths and philosophy, or maths and statistics, then you do questions 1 to 5, which are typically, and now this is really rough, but as a general rule, you can expect one to be on A-level, question 1, the multiple choice section, to be on A-level topics including geometry. Question 2 is typically more abstract and may include integer problems. Question 3, functions and calculus is really common. Question 4, often geometry, trigonometry, that kind of thing. Question 5, it's generally quite abstract, not really related too much to A-level, and that's the question people do often struggle with. And then if you're doing maths and computer science, you do questions 1, 2, 3, 5, and 6. Question 6 often involves algorithms or abstract problems, integers. Another one is logic. They like to ask truth or lie questions, at least they did used to in the past. And then if you are doing just computer science or computer science and philosophy at Oxford, then you don't do questions 3 and 4, and instead you do question 7, which often looks at algorithms and more like computer science-based logic in that question. So what we're going to be doing now is comparing a mat question, a long mat question, not in terms of, we're not going to do this particular question, but we're going to look at the style and the content of the question and compare it to an A-level question of the same or similar topic. So let's look at the A-level question first. Chris, do you want to quickly talk us through that?
Yeah, so we've just chosen an A-level topic on, well, just an A-level question on a particular topic, which is polynomials, in this case a quadratic. And we'll look at some questions from the admissions tests on similar topics. And just to quickly describe this so we can compare the others to it, this is an 8-mark question, so you'd get between 9 and 10 minutes for it. And in each part, if we look at what we're asked to do, part A is express it in a particular form, so completing the square. Part B is sketching it and finding the point where it crosses the axis and where its turning point is. So those are some simple calculations. And then part C is finding a distance between 2 points, which is also a straightforward calculation. So you're told exactly what to do in each part. You're given the marks for each part. And also the function itself isn't that scary. It's just an ordinary quadratic. So now we can maybe compare that to a mat question, which I think we've got coming up. So what makes this mat question different? Well, it is on a similar topic. It is on polynomials, in this case a cubic. It is longer. You'd have 20 minutes for this, roughly, as we already saw. And it's harder in a couple of ways. So if we look in the first line at the definition of the function f subscript k of x, well, firstly, there is this subscript. So there's this number k it depends on. And so we don't actually have one cubic. We've kind of got a family of cubics. And which one you get will depend on what value of k you choose. And also, if we look further down, say in part 3, we can see we're putting in multiple different arguments into these functions. We've got 1 plus t and 1 minus t. We also changed the value of k in there. And in part 4, we see it's not just about polynomials, it's also about transformations. And actually, if you went on to do this question, you'd also find out there's some, you'd have to think about symmetries of the curves when you're solving it. So there's a couple of slightly harder topics there. Just a couple more things that make this slightly unfamiliar. So you then define a second function, a of k. They like to do this. You then define something else, and that corresponds to the absolute value of the shaded area in the picture. And in a lot of these parts, if we look at part 2 and part 5, what you're asked to do is explain why, And at the end, it says you're not required to calculate something explicitly. So what they're looking for there is for you to give a short explanation in words that demonstrates your understanding of what's going on at a deeper level, rather than just doing a bunch of working out. And if you did do a bunch of working out, you just waste your own time. The last thing to say is they haven't actually given you the marks for each part, so you just have to, you just do as much as you can. You can't see, this bit's worth most of the marks.
Yeah, I guess it requires a certain level of intuition as to how long that part should be. You've got to have a real good understanding of the question.
Yeah.
Okay, right. We are going to move on to the other tests. Some of you may not have been here at the beginning when we just had this up at the beginning. If you are interested in finding out more about the admissions tests, but also comparing courses between Oxford and Cambridge, finding out what the degrees are actually like. So we've described the degrees in quite a lot of detail and the topics that you would cover. How to write an effective personal statement, which I'm sure is really relevant to a lot of you right now, with real examples from successful students, details about the tests and Oxbridge interviews, including sample interview scripts. Then I recommend just scanning that QR code right now, grabbing yourself a copy of the Oxbridge Formula book. Chris and I are authors of the book, so we're slightly biased, but it is a really good book, and you can see the reviews that it has on Amazon. So I'll just leave that up there for 10 seconds, and then we will move on to look at the CTMUA and the CSAT next. All right, so CTMUA, what is it all about? So it has the same A-level content as a MAT, but it is in a fully multiple choice format, as we said. Then again, it's elimination. You know, like often when you have multiple choice questions, you might think, okay, elimination is going to be a good way to do this. We found that for the majority of CTMUA questions, elimination isn't a good way to do them because they just give you so many options. It's normally like A to H or something like that. And they cover basically like every possibility that you could have, and we'll see an example in a second. So elimination isn't really a good way. They're actually intending you to do the question from scratch. It seems like the multiple choice is there to make it easier for them to mark rather than make it easier for you to do, if that makes sense. And it's an extremely time-pressured exam. If we just have a quick look at the topics, paper 1 covers things quite familiar to you from A-level or the IB. So we have functions and calculus, geometry, sequences, logs and exponentials and inequalities. But paper 2, we're looking at these slightly more unfamiliar type things. So we asked you to look at necessary and sufficient conditions already. That's not something that's covered much at school. When we say negating statements, we mean quite long, convoluted, logic-based statements that you have to kind of find the opposite of and figure out which one of these phrases best represents that negation. We do a bit of this at A-level, so looking at flawed proofs, but now the proofs are longer and the kind of flaws are more subtle. And also counterexamples, and we'll see that later on today, is something that you have to be able to construct and find quite easily to disprove a particular claim. So all of this is actually not taught at A-level, and the admissions testing service have actually created, I think, a 70-page document that you can kind of read, but because of the fact that it's just not taught anywhere else, it's kind of its own syllabus. And it's also the kind of thing that we have our own 2-day course on paper 2 of the CTMUA. So if you did join us and wanted to study with us, we would go through all of those topics and more for that paper. So what we're going to do now is compare a CTMUA question on a similar topic.
Yeah, so if we compare this one to the A-level question and the MAT one we saw before, it is still about polynomials, but and this one is, as you see, it's multiple choice and it's shorter. You have less than 4 minutes for this. But also, how have they made it kind of trickier than A-level? Well, it's not about a specific polynomial. It's about sort of a general polynomial, P of X. And you can see it's also not just about like working anything out. There's this connection with logic. You need to know what a necessary condition is. You're given 3 statements. You're asked which of them is a necessary condition for the function to be increasing on a particular range. And the last thing is, although it says, when it says which of these statements is a necessary condition, you might think that means it can only be one of them. But actually, if you look at the options, it's allowed to be two of them, or even all three, or none of them. So that means you have to check each one separately, which makes elimination impossible, and B means you can't just stop once you've done one. You have to do, it's basically 3 questions in one. It's kind of longer than it looks.
Okay, great. And now let's look at the CSAT. So the CSAT contains year 12 math mainly, but also some year 13 math, so like integration, differentiation. Quite similar to the kind of interview questions you would get at CSAT, but you're now writing your answers down. Although it's suggested that you do 5 questions from part A and 5 from part B, you essentially would do as much as you can in the time. And then with the CSAT, you would actually take the exam. Well, they would have the paper with them when they're interviewing you, and they'll help you, guide you along and try and get you to finish the questions that you didn't manage to finish when you were doing it yourself. The questions give very little guidance. It's normally like 2 lines in a question, 2 or 3 lines. And then, you're expected to do the rest on your own. So there's not many hints or kind of parts. Many questions do test your proof skills. So here is an example question.
So again, we've got a question about polynomials. So how is this one different? Well, we can see you're just given a single task, but it's kind of written over 3 lines. So you've got to read and interpret a bunch of stuff. You do have, say, up to 18 minutes for this if you're doing 5 questions. And the actual instruction in the question at the very start is give an example of. So you're kind of what you're asked to do is basically to construct a polynomial that meets certain conditions. So there's 4 conditions, A, B, C, and D, and you're asked to construct a polynomial of the smallest degree that meets all 4. And this is a kind of CSAT-y thing to do. Like, it gives you some constraints. You just have to make something that works according to the constraints. You have to figure out a lot yourself. Like, you'd have to figure out what kind of degree you can aim for, maybe. You also have to understand the language in the question. There's no clarification. You have to understand what it means by inflection point. So the second derivative being 0. And you've got to basically unpack all these 4 constraints and then figure out what your polynomial has to look like.
Yeah, exactly. And I think with the inflection points, some people might assume they're like stationary inflection points, so the gradient has to be 0, but actually it turns out that they're just talking about general inflection points, which is when a graph goes from convex to concave, and we're going to actually see another one of those later on today as well. So that's kind of what the questions are, how they differ from each other. How are these tests really used? So the MAT and CTMUA are used pre-interview to decide who to invite to interview. And the CSAT is used at interview, where as I said, interviewers might continue a question with you that you struggled with, or extend one that you did already complete. But all 3 of the tests are used post-interview and combined with your interview performance to decide who to make offers to. I literally cannot stress enough. These tests are far, 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 far more important than your personal statement at Oxbridge. It's like, I would say it's about 5% personal statement, 45% admissions test, 50% interview. Like, obviously I just made those numbers are kind of made up in the sense that there's no actual like ranking of them, but in terms of how important those 3 things are, that's how important I'd say. I mean, it's very insignificant, the personal statement, for a maths or computer science applicant to Oxbridge, but obviously it is important to do a good personal statement for your other universities. What I'm trying to get at there is, if Oxbridge is really what you're trying to go for, then don't spend all your time on your personal statement. Problem solving is what you really need to be getting good at. So what is the PROF methodology? Well, P stands for problem planning. What do we mean by problem planning? So it's likely that when you have written an essay at school, you were told to create an essay plan, but you don't very often hear about creating a plan for solving a problem. And we believe that if you think about a problem the right way, it is possible to plan before you write down. So it's like essay planning for maths and physics, knowing what you'll be doing before you start writing. So actually thinking before you start writing. Figuring out what the question is really asking you, I think, is part of problem planning. Figuring out what the key information is, seeing how the different parts of the question are related, because often that gives you a lot of hints as to how to proceed. What is the logical starting point or the logical route through the problem? And this kind of touches on the same thing. What is the flow? What are the links between the different parts? And then we're going to look at Dr. A, which is draw a diagram that will help you, rewrite a complicated expression to make it more readable, and articulate the abstract, which is take something which looks really abstract and put it into words, put it into plain English so you understand what you're doing. And we're going to be looking at that through this question. So what we're going to do now is give you about a minute to read this in silence, a minute and a half to read this in silence. If you can put in the chat, say just done when you're finished reading it, then when quite a few people are done, we will carry on. So read this question and we're going to go through it now. Oops. Okay, so a few people are telling me they are done. So, and I have my alarm there. Sorry, I've got my humidifier here because it's just so hot, but it looks like there's like smoke or something here. So apologies for that. Right, so yes, it looks like a lot of people are done. Excellent. So let's get started with this question then. Chris, if you want to start.
Yeah, so, well, when we're first reading this, at the very start, we've got a few functions defined. And they're all written in terms of letters, and we see they're used later on. And especially in, say, part 1, that's a very complicated expression that's all in terms of these new letters that we've just been given meanings for. So it's kind of hard to unpack initially, just looking at it. So, okay, what can we do to help with that? Well, we've got this principle of articulating the abstract, so maybe we could use that. So can we articulate what all these functions do in a simple way that we can remember when we do the rest of the question? Well, if we look at P, it's just P of X just adds 1 to X, so P is just doing +1. And M likewise is -1. And S, so this is the one that looks a little bit more complicated. If we look on, so it says S of X and Y and Z equals, then on the right-hand side, the answer is always either Y or Z. So it's actually just selecting one out of Y and Z, and it selects Z if X is positive, and Y if X is negative. So X is like the switch. And it's also probably not a coincidence they use the letters P, M, and S for these, because we got plus and minus and then kind of a selector. So we could also state S as, I think we've got this written down. It's on the next page as well. It just selects the last term of X is positive and the middle term otherwise.
So yeah, I think the point here is that wasn't hard, but if you think about it like that, then that long expression that we're going to see on the next page is just going to be much easier because you wrote this little note down.
Yeah, so just before we go on, and so this is kind of our planning. Part of our planning is just to understand what the functions do. We've done that. Before we look in detail at any other parts of the question, we just want to plan, like read through, think about what we're going to do in each part, like how do the parts tie together? What do we see that gives us a clue as to what we're going to do? So the first thing is, the instruction words are always quite clear and useful to look at. So what's each part asking you to do? Part 1 is asking you to show the value of this long expression is 2. And part 2 is asking you to find the value of, well, they've got this new function f that's defined, but it's just f with 5 and 2 inputted. So it's just finding the value of that. So those are kind of numerical tasks. Does that mean they're going to be kind of easy and not really matter? Well, they may or may not be easy, but they definitely do matter, because often the structure of a math question is, at the beginning, something's defined, and then you do some simple-ish calculations with it. But what you're meant to have been doing when you're doing those calculations is learning something you're going to use in the later parts, which are a bit more involved. And if we look at 3 and 4, what are the instruction words there? Well, 3 is saying to give a formula and 4 is saying to define a function. But some of the more interesting words are 3, you're giving the formula that works for all integers a and all positive integers b. And then the other task is explaining why it holds. So you're doing something for all integers, so it's quite a general task. It's like the general case where 2 was the specific case. And also you've got to give an explanation. It's one of those explain type questions. And then 4 is very similar. You're just doing it for a new function. So those are the instructions we're given. And then we can also look in a little bit more detail. We just kind of said when we're doing 1 and 2, we need to look for something that's going to help in 3 and 4. In particular, in part 2, what we'll have done will be to have evaluated this function f. So while we're doing it, we're meant to look for some kind of pattern, maybe, that will help us evaluate the general case. And then if we look at this function f now, so that's what's used in parts 2, 3, and 4. What do we notice about it? So we've got to think, okay, we're planning what we may be going to do in the question. What does it look like this function f is going to do? Okay, it's a bit hard to read initially. I think the main thing to notice is there's an f on the left-hand side. That makes sense. There's also an f on the right-hand side. So in a sense, the function f is being defined in terms of itself, or the function f on a and b is being defined in terms of the value of f on a and another value. So what kind of function what kind of function definition does that make this? It makes it recursive. So it's a recursive function definition. So that means we know we're going to have to look out for recursion when we're doing parts 2, 3, and 4. And finally, 3 and 4 also, maybe there's some relationship between these parts. It actually says in part 4, you're meant to do it in a similar way to f. So what does that suggest you might be doing in part 4? Well, maybe you've learned something from doing part 3, and you can just adapt it slightly to make the function g. That should maybe be our plan. And also, what are we looking to change? Part 3, you've got a function that works for all positive integers b, and part 4, it's for all integers b less than or equal to 0. So clearly we're looking for how the positivity or negativity of b matters to the answer. That's what we've got to be looking out for when we're doing those parts.
Okay, yeah, I think that's really helpful. So what we've just done right now is what you should do before you even like put pen to, I mean, you might, okay, fine, you might write down the definitions of P, M, and S, but this is the planning that we were doing before we even started writing anything down. So let's move on.
Paul, do you want to?
Yeah, okay. All right. So in prof, we've got problem planning, reflective, reflex. We're just going to skip for a second. We'll come back to this. The O in problem planning is outline and organize. So what we're going to talk about is how do I lay my work out? How do I make it clear? What diagrams do I include? How do I make sure my reasoning is valid and complete so that I don't have any missing steps? And I think particularly, and a couple of people have asked us in the Q&A as well, is what does a justification look like? So how much is enough for me to write, or what should I write? So we're going to be looking at that in the next few parts. Yeah.
Yeah. So we'll actually look at each of the parts of this question, and we'll show how you might go about solving it, but also how you might lay out your answer, what you'd be expected to write. So part one, we've got to find the value of this thing. We said this is the bit that looks scary, but maybe the way we've rewritten our functions will help us. So we just noted at the top, p is doing +1, m is doing -1. And also in this function, we can actually see sometimes they're applied twice or one to the other. So we just need to remember, okay, if we do p twice, we're getting +1 +1, that's +2. Do m twice, that's -2. So that's kind of what we're looking to happen. And when we're evaluating this big, long expression here, well, it's really hard to refer to. Like I've been calling it the expression. But it's so long, you don't want to keep writing it out. So I think the very first thing I might do for my own working or for writing out the solution is give it a name. So let's call it A. But the other useful thing we can do is, so in A, we can see the function on the outside is S. So it's S and then a big bracket and then a big closing bracket. And inside there's 3 terms, which makes sense because there's 3 inputs to S. So, and each of those also looks a bit complicated. So we'll just give them all short names as well. We'll call them P, Q, and R. And so if you're thinking about how you're going to do this, you might think, well, all I'll do is I'll work out P, and then I'll work out Q, and then I'll work out R, and I'll plug them all into S and see what I get, which is fine. It's not quite the quickest way, though. How can we speed that up? Well, the thing we remember about S is it always chooses one out of the last 2 inputs. So it's going to choose one out of Q and R. So that means it would be a waste of time to evaluate both because we're only going to keep one of them. So we're going to do what a computer scientist might call lazy evaluation, which is only working out an input when we know we need it. So the input we do know we need is P. We definitely need to know the value of that because it decides which of Q and R we keep. So we'll start with P. So to start working, we'd say, okay, here's what we want to show. We want to show A = 2. And the first thing we're going to do is evaluate P.
I just want to, just to butt in, I want to emphasize that these things that we're writing is actually what you should be writing in your interview, admissions test paper, because it's a show that question and you're showing something equals 2. So if you don't show clear working, you're not going to get full marks for it. So having clarity with what you're doing is important. And I'm sure your teachers would love you writing your work out clearly in your A-levels too. So we're telling the examiner what we want to show. We want to show that A = 2. And then, as Chris said, we're evaluating P. Yeah.
So when we look at P, it's also got the function S on the outside and then 3 inputs. And each of them is just made up of P and M applied to 0. So we can work them out quite quickly. We've got P of 0 is 1, and then -1, and then -2. And we just color-coded these for your convenience so you can follow them through in the working. So what do we do with S? We look at the first input, and if it's positive, we keep the last input. And 1 is positive. That's something we should note we're using. And so we keep -2. So P is equal to -2. So that's P. And then why did we work out P? Well, it's in order to evaluate A. So now we go about plugging this into A. And since -2 is negative, in A, we're going to keep the second term, the middle term, which is Q. So now we know A is just equal to the value of Q, and we just have to work out Q. So we'll just say evaluating Q, it's got the same form as P, just with slightly different inputs. It's 1, -1, and 2. Again, 1 is positive, so we keep the last term, which is 2. So we've shown that Q equals 2. And you might be tempted to just stop here, and maybe you get all the marks, but it's normally a good idea to restate your conclusion very clearly in the form you said you were going to prove it. And what we said we were going to show was A = 2. So we're just going to conclude, since A is equal to Q, A is equal to 2 as required, as we were asked to show. And restating your conclusion is really good because it shows you know you've finished. And you can check for yourself you actually have finished. So let's go on with the rest of the question. So just before part 2, they define this new function f. And well, it looks a bit complicated. There's a whole bunch of brackets in there. So a little bit scary. Can we rewrite it? And in our Dr. Ray, we've got rewrite to make readable. So we have summarized what P and M and S can all do. So I think the P and the M are relatively straightforward to put in. So what have we got in here? We've got a P of A, and then inside in the sort of depth of the function, we've got this M of B, and there's also an extra P that's added to that whole last term. So if we just put in the pluses and minuses, what have we got? We've got S of B and A plus 1, and then the last term is F of A and B minus 1, all plus 1. And that last plus 1 comes from the P on the outside. So that's fine. It's a little bit better. It's still kind of long. Not that easy to just read off what it does. So can we rewrite it anymore? Well, we said what this function S does. And S splits into cases. And often with cases, it's a good idea to write out explicitly what each of the cases is and differentiate between them clearly. So our two cases are, if B is positive, we only keep the last term, which is F of A and B minus 1, all plus 1. And if B is 0 or negative, then we just keep the middle term, which is just A plus 1. So I think this immediately makes it look simpler. The first line just simply relates the value of F at B to the value at B minus 1 in a fairly straightforward way. And if we just remind ourselves, we said this was going to be a recursive function definition. And this is, if you've ever dealt with recursive functions before, this, like reading it off in this form is going to be a bit easier to work with. And also, if B is 0 or negative, then we have a very simple answer. It's just A plus 1. So now let's go on and use that. So we're asked to find the value of F of 5 and 2. So we're just going to use the form we just wrote F in. By the way, it would be an absolutely good idea to literally write it like this in your answer and start from there. So let's plug in A equals 5 and B equals 2.
So I just want to remind everybody that when we're doing numerical calculations, we're actually going to be thinking about how we can generalize. So we're really looking at what's happening. And although this is a relatively easy example, it's just a demonstration of the way you should be thinking when you do questions like this. So yeah.
So we plug in 5 and 2, and that means 2 is bigger than 0. So that means we're in the first line of our definition of F. So that means let's see, we do B minus 1, that's 1, and then we add 1 on the outside of the whole thing. Then 1's bigger than 0, so we do the first line again, and we get F of 5 and 0, and we've got another plus 1, and also the plus 1 from before. And now 0 is equal to 0, obviously, so on the second line, and that means the function just gives us A plus 1. And that's good, because when you see a recursive function definition, you know at some point this has got to stop. The recursion's got to stop, or I'll never get an answer out. And now we've seen it stops when we get to 0, so that's good. And our answer is 5 plus 1 from that last line, plus 1 is 8. So that's our numerical answer. But as Pavel said, the more important thing is what did we learn from this that we can use in the next part? So if we just, you could think of this as reflective reflex. We're reflecting on the question we just did and asking what we learned. And let's just try to summarize what the process of working out this function was. So we can see we've got a couple of steps where we just decrease B by 1 and then add 1 on the outside. And we just do that again and again. And it stops when we hit 0. And we've got a plus 1 for every time we did that. And then at the end, when we hit 0, we just get 5 plus 1. Or in general, it would just be A plus 1. So that's our last step. So now let's go to, we'll keep this in mind, and now let's go to part 3. So part 3, we're asked to give a simple formula for the value of F of AB for all integers A, all positive integers B, and explain why it holds. So positive is good because the example we just did was for B positive. It was when B was 2. So we'll just start with what we learned from the last one. We said when we're working out F, what we do is we start with B and we just take 1 off each time we use the recursive step. So it might be good to label these two steps separately. We've got the recursive steps in which we decrease b by 1 until we hit 0, and we add 1 to the output each time. And remember, we're thinking about what this gives us for the value of f of a and b. So what does this add to the answer? Well, how many times do we have to decrease b by 1? It's b times. If you take 1 off b times, then you'll get to 0. And we've added 1 each time, so we've just got plus b from doing those steps. And then at the end, when we get to 0, we get a plus 1. And that means that the final answer is going to be just those two things added together. So a plus b plus 1. So in this blue box here, we've got our answer for f of a and b. That's one thing I asked for. But also the previous steps are our explanation for why it holds. So your explanation can just be a few lines of English. It might be at school you've seen how to do a kind of proof related to this, like a proof by induction. That's not actually what it's asking for, it's just asking for an explanation. But your explanation does have to be clear and complete, like this one is. So let's quickly go on to part 4. Part 4, you can see we've got a bunch more stuff on the screen. What's the list for? Well, at the top, I've just copied in our kind of rewritten, clearer definition for f. Because we said, okay, we probably want to start with that and then just change it a bit to try to make g. And I've also put in this yellow box, what do we want g to do? Just to remind ourselves, it's going to do a plus b if b is less than or equal to 0. So for example, if b is minus 2, what you want is, you're basically doing 5 minus 2.
You want 3, yeah.
Yeah, which gives you 3. And on the left in this pink box, we've got what we just said the function f does. You add b lots of 1, then you hit 0, and you add 1 to the output each time. And we're just, it's also good to go, so these are the things you kind of be looking back at in your previous working when you're trying to find out what g is. So we've got a calculation as well we can compare to. So finally, what are we going to change when we do g? Well, when we're doing f, we added b lots of 1. Why is that not going to work? Well, because b is negative now, or 0. And you can't add negative lots of well, you can't do adding 1 a negative number of times. If you think of it as the number of times we did this, you can't do it a negative number of times. So, but we do want to get plus b. So our plan maybe is minus b is positive. So what if we did minus b lots of minus 1? So that's one way to come at this problem. And what does that mean our function is doing? But also our function f, we were decreasing b by 1 each time. Is that something we can do for g if b is negative? Well, no, because if you start with, say, minus 2, and then you decrease it by 1, you get minus 3, minus 4, minus 5. You're just getting smaller. It's going to continue forever. You never stop. At some point, we need to get to a different case. So what we'll do is instead increase b by 1 each time. And before it was going until we hit 0, technically we can't, because our function f treats 0 the same as negatives, actually we'll have to stop when we hit 1 instead. Because it would think 0 is just like a negative number. So that gives us a plan, and then we can come up with a first go at g. So we're just going to write down, just with this in mind, what you might have written down for your first go at g. So we're increasing b by 1 each time, adding minus 1 to the output each time. Let's look at what function that gives us.
Do we want to say about minusing 1 from the output?
Oh, did I skip that? It's just saying if we're increasing b by 1 each time, then before we were decreasing b by 1 each time, adding 1 to the output each time, so that we got lots of plus 1s. Here we're saying we want a bunch of minus 1s. So we're just subtracting 1 from the output each time.
Yeah. All right.
So, and that especially makes sense because the more negative b is, the smaller we want our answer to be, because it's meant to be like a plus b. So our first try might be, when b is negative or 0, we want to do a recursion, we want to increase b by 1 each time. So we're doing g of a and b plus 1, and we're subtracting 1 from the output each time. So that's our minus 1 on the end. And that looks a lot like our definition for f, so we're confident we can make that out of our functions s and p and m. And we also want a case where it stops. So when b gets positive, it's got to do something else that doesn't depend on g, so the recursion stops. So maybe your first try, you just choose that to be a and then see what happens. Because you know you want an a in the answer, because your answer is meant to be a plus b. So we'll just choose a. And then, okay, what you always need to do is check if it works or not. So let's check with just the numbers we were using in the example before, 5 and minus 2. What do we get? We get g of a and minus 2. That puts us in the first line. So we do the recursive step. We add 1 to minus 2 to get minus 1, and we subtract 1 from the whole thing. And then minus 1 is also negative. So then we add 1 to minus 1 to get 0, and subtract another minus 1 from the whole thing. And now we've got 0, and 0 is treated the same as negative. So that's also in the first line. So we increase that to 1. We've got 3 minuses on the outside. And then 1 is positive, so we're in the second line, which is going to be a, which is 5. So we get 5, and then minus 3 lots of 1 is 5 minus 3. And is that what we want? No. We wanted to get 5 minus 2, and we got 5 minus 3. So something's gone wrong. So how could we kind of summarize what the problem is? Well, we subtracted one too many times. And that's because we're not stopping when we get to 0, we're stopping when we get to 1. So we need to somehow correct that issue. So I think the most straightforward way to try to correct it is we'll just try to get an extra plus 1 from somewhere. I think the easiest way to correct that is just to, instead of adding a at the end, we'll just add a plus 1. So we'll just quickly check if this works. So adding a plus 1 instead, we kind of suspect it is going to. So we do it for 5 and minus 2. For the first couple of steps, it works out the same as before. So we get to g of 5 and 1 and 3 minuses. And then g of 5 and 1 is the second line, so that's now a plus 1. And the plus cancels with 1 the minuses, we get 5 minus 2, which is what we wanted. So what remains to be done? Well, we've got to write our answer in terms of S and P and M. So if we just look at our second try at the top here, firstly, wherever there's a plus 1, we can just, we'll just do the cases first. So we've got 2 cases. This is the second line when B is positive. So it should be S of B, and then the second line should be the third thing.
So, okay, let's just clarify. So remember, we're writing it in terms of S, and if you remember the definition of S, it selects the last of the 3 things if the first one is bigger than 0, and then the middle things otherwise. So if B is bigger than 0, why don't we let B be our selector? So that's going to be what's in the first term here. And then we're saying if B is greater than 0, then you always pick the last term. So the thing that you pick there has to be at the end, a plus 1. And in the other case, is what you have in the middle. So that's how we've kind of constructed our definition there.
Yeah, exactly. And we also notice we've got these pluses and minuses we can maybe write back in terms of P and M. So we've got a B plus 1 that's going to be P of B. We've got an A plus 1 that's going to be P of A. And then that middle term has a minus 1 on the outside. So it's going to be M of the whole of the rest of that term. So if we put all those in, then we get to our final answer, which is underneath. So we've got our P of B, our P of A, and our M in the middle term. And there are actually multiple ways to do this, but this one is one of them. And the other part of our answer is meant to be an explanation. But we did kind of do this for F already. So we'll just write it in the same way as we did for F. So we label our recursive step where we keep increasing B by 1 until we hit 1. We add minus 1 to the output each time. And how many times have we added minus 1 then? So minus B is like the size of B. So that's how many times we have to add 1 to get to 0. And then we do it an extra time. So that's minus B plus 1. And it's that many lots of -1. So the actual amount we add is going to be -1 times that. So cancel the minuses and we get plus b minus 1. And that's our recursive step. And then we've got a final step, which is when b gets to 1, we add on a plus 1. And we just show that, okay, if you add those together, we've got a plus 1 plus b minus 1 equals a plus b, which is what we've asked to get to. So we've explained why it works for all a and b less than or equal to 0. Okay, so I'll go on, Carl.
I was just going to say, do we want to summarize what we've learned in this question?
Yeah, so firstly, we've used our Dr. A method. Okay, we haven't drawn a diagram. In this one, you don't need a diagram, although sometimes you can draw things like a number line you're moving along, if that really helps you. But we definitely did rewrite to make things more readable when we had big, long expressions, and we articulated the abstract. So we put stuff into English, especially important when you need to give an explanation. We noted the form of the question, which is the calculation parts you need to reflect on and learn from and draw on when you do the general parts. And we also saw kind of a way to summarize how a recursive function is working, explain what it's doing. So kind of split into the recursive step and the sort of final step at the end.
Okay.
Carol, was there anything you wanted to add?
No, that was really good. I was wondering if everybody could put in the chat to me one thing that they learn in this part of the question that they'll take away and apply when they're doing their own admissions test preparation. So in the chat to me now, guys, one thing, and I will read out some of your answers in just a second. So just a quick summary of something you've learned that you will take away with you. Somebody said maths is hard. Oh wow. So many coming through. Oh, there's so many. I'm just going to read them as they come through. New ways to approach questions more logically. Letting letters represent long functions. That's so useful. Why hadn't I thought of that? Somebody says how to plan the question before writing the answer. Lazy problem solving or lazy evaluation. The ability to actually write down what I know about a problem can make it far easier to understand a problem. I'm a parent. I have no idea what's going on. So it says the Dr. A method of breaking everything down, not to give up on a question if I get it wrong first, is always a better route. Planning the problem before answering. So necessary versus sufficient conditions. Now, this was something we asked you to research. So can you please put in the chat to me right now, what do you think is the definition of a necessary condition, or necessary and sufficient, whatever you put? Let's see what people say. So put it in the chat. When you did your research, what did you think these meant? Put them in the chat right now. Okay, so I'm just going to read them out really quickly. Necessary means a condition must be met for an outcome to be able to happen, but doesn't mean it will happen. Okay. A necessary condition is a condition that needs to be present for an event to occur. Do we agree with that? I'm not sure. Chris, I'd love your sort of feedback on some of these. In the event of strictly X implies Y, X is a necessity of Y. Interesting. I'm not sure I agree with all these. Necessary condition is required for something else to happen, but doesn't guarantee it will happen. Yeah. A necessary thing is if X is true, then Y must be true. But which one's necessary and which one's sufficient? A necessary condition is one that is required for another condition to be true. A sufficient condition does not mean another condition is true, but it can be. Okay, it's really interesting. The way you phrase this is kind of different to how I would phrase them. Sufficient, an outcome that can happen, possibly if another has happened. I'm not sure. I don't know. Kate, sorry. Chris, what's your thoughts?
Well, maybe we could put this on the screen, but so a lot of people talk about one thing implying another, but then you have to be very clear which of those is the necessary condition. So yeah, it is all about implications. So suppose we have two statements, we might call them A and B, and we talk about necessary and sufficient when A implies B, for instance. And in this case, A is the sufficient condition for B, and B is the necessary condition for A. So if A is true, B must be true. So that makes B necessary.
And I would like to say that if A is true, then B necessarily has to be true, because if A implies B, then if A is true, B has to be true. So B is necessary in that case. It's necessary.
Yeah, you could also say you can't have A without B, which explains why.
Let's not overcomplicate.
Yeah, okay.
Yeah.
And likewise, A is sufficient for B, because as long as you have A, that's enough for you to have B.
Yeah, because the word sufficient literally means enough, right? So it's enough for A to be true to know that B has to be true.
But when you have a question about necessary or sufficient conditions, or both, it means it's often useful to translate it back into implications between statements. So it makes it easier to keep track of what you want. So we just got some examples here of some necessary and sufficient conditions. So for instance, if x is 5, then x squared equals 25. So that makes x equals 5 sufficient for x squared equals 25. And it makes x squared equals 25 necessary for x equals 5, but not vice versa, because we don't have x squared equals 25 implies x equals 5. It could also have been minus 5. So it's showing that something can be sufficient but not necessary, and vice versa. And likewise, the second one we've got being an integer is sufficient for being a rational number. Being rational is a necessary condition for being an integer.
Because I want to emphasize that if you're an integer, then you must be rational, and therefore the bit at the beginning of the implication is a sufficient bit, and the bit at the end is a necessary bit. Yeah.
Yeah. And lastly, sometimes things can be necessary and sufficient. So if a quadratic has no real roots, then its discriminant is negative, and also vice versa. So both of those are necessary and sufficient conditions for each other.
Great. Okay. So we thought we'd just give a simple definition there. This is the kind of thing that we cover a lot more of in our CTMUA paper 2 course, and you will do at university if you're doing maths or computer science. So it's kind of stuff that you will need to know eventually. So let's have a look at this question then.
Yeah, so this is the question we looked at before, and it says it is about finding which of these three statements is necessary, and whether it's necessary for P of X to be increasing on the range X between A and B. So, okay, we want to do some planning here. So what are the things we might think about? Well, firstly, we do have to read the question carefully and see what keywords there are, see what it's really asking. So if we do that, what are the kind of keywords? We've got, okay, let's talk about polynomials P of X. So anything that applies to other functions doesn't matter, only polynomials. Got necessary condition, we talked about that already. It's got to be increasing. By the way, actually, it doesn't matter whether it means strictly increasing or not, if you worry about that distinction. And also, it's on a particular range. It's not necessarily for all values of X, just X between A and B. And next, we want to sort of, we got these three statements, and they're a bit abstract, just in terms of letters. So again, can we articulate the abstract? Can we articulate what each of them is really saying in words? And here maybe it helps to, we'll look at a diagram in a second. It helps maybe in your head to be thinking about, okay, maybe we've got like a graph of y equals P of X. So one is saying, well, it's just saying P of A is less than or equal to P of B. So the curve is kind of higher up at B than it is at A. And two is talking about the gradient, the derivative of P. So it's saying the gradient's bigger, so it's kind of steeper at B than at A. Well, we're talking about upward steepness, so how much it's sloping up. And statement 3 is talking about the second derivative, and sometimes that can be hard to put into words. Again, we'll look at a picture in just a second, because that's the D in Dr. A. But one way to think about it is the second derivative is describing how much it's curving upwards. So it's saying it's curving upwards more at B than at A. So as I've just said, sometimes it could also be good to have an actual picture to illustrate some of these things for yourself. This is just a sketch you can do in 2 seconds on a piece of paper. And when we're doing this, you might think, well, we don't know what the graph of P looks like. I've put one here. That could be a cubic or some higher degree polynomial. But the point is, like, I'm not meant to be sketching the function P of X. I'm just sketching an example that's going to be useful for me. And the reason I've sketched this is kind of like the middle bit of a negative cubic, is because it shows the second derivative changing. So we've got kind of a minimum, and at the minimum, you know the second derivative is positive. And you can also see that the curve's curving upwards. It's been coming down and now it's going upwards. It's curving upwards. In the middle, it's basically going straight. That's where the point of inflection is. That's where P double dash is 0. And at the maximum, you know P double dash is negative because it's curving down instead of up.
So yeah, in the school, you may have covered it as like, if the graph is concave, then F double dash would be less than 0. If it's convex, then F double dash will be more than 0. So in the middle, you have your point of inflection, which if you remember in that CSAT question, we were talking about points of inflection. That's that point where it starts going from convex to concave is that point.
Yeah, I should just say here, it doesn't matter so much in this question, but I've said what are useful example functions to have in mind. So firstly, we talk about polynomials. Don't just fixate on one. So this one's useful. It's also useful to think about maybe the shape of a quadratic, have that in mind. Also, like linear and even constant functions count as polynomials. It's worth remembering that because sometimes special cases can matter to the answer. But if we just quickly look at how we'd actually, so now we've kind of done our planning, how do we actually answer this now? Well, we've kind of restated 1, 2, and 3. And we said we're going to ask if they're necessary. So ask if they're implied by P being increasing. So we're going to check, suppose P is increasing, does it imply each of these 3 things? Let's go on to the next slide, maybe. And just summarize what we're checking. We're checking, so for instance, for statement 1, is it correct that if P of X is increasing, then the curve must be higher up at B than it is at A? And while we're checking each of these, you're kind of thinking in the back of your head, like, to check it's to check like an implication, like if then, often the easiest way is actually to check for a counterexample, so something that doesn't satisfy the implication. And a counterexample is always something that kind of satisfies the if part, but not the then part. Something that, so for instance, for 1, it would be a polynomial that is increasing on some range, but it's not higher up at B than it is at A. So actually that first one we can kind of see, yeah, we're not going to be able to create a counterexample to that. If something's increasing, then it's definitely, it gets higher up the further you go to the right. So it's got to be higher at B than at A. Worth saying here, we're using the fact it's a polynomial, so it's defined on all the points in between. That does matter. But 2 and 3, can we construct a counterexample? Well, I made sure to draw a nice function before, which had lots of values for, like it had positive and negative gradient in different places. It had positive and negative second derivative. And if we just use that example again, I can pick some points A and B that do make counterexamples to 2 and to 3. So statement 2, what we're checking is if the function is increasing, does it have to be steeper at B than at A? So a counterexample would be something where it is increasing, but it's not steeper. So maybe it kind of leveled off. And that's exactly what we see. It's in this kind of cubic. If you choose A in the middle and then B at the maximum, it started off steep and then it got flatter, even though it was increasing the whole way. So that's a counterexample to 2. And to 3, well, maybe we could even just look at the same 2 points. At A, we said our second derivative is 0, and at B, it's curving down. It's kind of more concave. So that means the second derivative can decrease. And that makes it a counterexample to 3, which says the second derivative should be bigger at B than at A. So let's see, 2 and 3 don't have to be true. So that means they're not necessary conditions for it to be increasing, but number one, we said it is, and that makes the answer, it's statement one only, so it's B. But that was made a lot easier for us because we did some planning at the start and we found a nice picture for ourselves.
Okay, great. Yes, I think in terms of learnings for this question, somebody actually put in, wouldn't it work just to use counterexamples, which are mini sketches instead of actual equations? Yes, absolutely would. And I think we were just showing, this is an example of a sketch which shows.
Yeah, I didn't actually write down the equation of that curve, like it doesn't matter.
Yeah, we don't have an equation. We just written like, what's true about. We wouldn't, we wouldn't do this working necessarily. All you would need to sketch to kind of show. All you would need is a sketch to show whether these are true or false, but we've just put that there so you can see what we're doing. Does that make sense? Cool. So what we are going to be looking at now. Yeah, sorry.
Were you going to ask what everyone had learned from the question? Or?
Oh, yeah. Why don't we do that? Okay. So one learning you took from this question, guys, one learning that you have taken. Somebody says, what if A is before the maximum point and B is after, but not as low as A? Then actually the equation would be increasing, and it tells us in the question that P is an increasing function on that range. So you can't use that. So somebody is saying, don't jump to conclusions. I'd love to hear more. The person who said that, what do you mean by don't jump to conclusions? So tell me a little bit more about what you mean. I'm looking for more people to put in the chat to us what they have learned from this question. Diagrams really help. Yes. Okay. If that's the only thing you learned today, that is so useful. Write the condition out in words, rewrite the question to make it easier to understand and make it more approachable. 100%. That's our Dr. Ray coming out there. Great. Diagrams can really help with counterexamples, or really help and counterexamples, but I think they can also help with counterexamples. Somebody's learned. Somebody didn't know what increasing meant. Okay, an increasing function just means the gradient is positive on that range. Evaluating all your options, yes. Analyze a situation tactically. What do you mean by that? I want to know some more specific. Somebody's saying, I'm saying that even if PB is greater than PA, it doesn't mean PX is increasing across. Right. Okay, you've done it the other way around. You're saying, what if we assume that P of B was bigger than P of A? Then can we show that P of X is increasing? So you're actually showing it the other way. Here it's saying, let's assume it's increasing. Can we show number one? And you were saying, if we assume number one, can we show the thing we were assuming? So you did it the other way around. And you've got to be really careful in these types of questions, not to get it the wrong way around. So hopefully that helps. Somebody has said they know what necessary conditions are, also sufficient, not suitable. Some information maybe more detailed than required, such as, such as P of X being polynomial, implying it's continuous. What do you mean by maybe more detailed than required? Because it was really important it was a polynomial, because if it had been discontinuous, then we couldn't have necessarily applied this logic, because if you have an asymptote or something, then it doesn't necessarily work. Write statements in context to visualize necessary and sufficient conditions. Okay, perfect. Right. There wasn't that many people who wrote to us in that bit, so hopefully people did find that useful. Right. While we have another. Oh, hold on one sec. Okay. All right. Okay. So now we're moving on to, we've done the problem planning for both of those. We're now moving on to reflective reflex. And when we're talking about reflective reflex, we're looking at what did I learn from these questions? So we did two questions just now. What did I learn? What was it about the question that made this method work? What have I learned from this question that I can use in another question? What would the next part of the question be? And so on. And that fourth question there is really key. How could I extend this question? If I extend it, can I actually solve it, or does something go wrong? If I make a part 4, part 5, part 6, can I actually solve those parts, or what messes up? So Chris, I
just want to add to that. One thing that does is it makes each past paper question even more valuable, because you're not just doing one question, you're doing as much as you can make out of it.
Yeah, it's you're really maximizing your use of each question, just as you're going to maximize your summer this summer. Yeah, Chris, go for it. So talk to us about your reflection, your reflective process during this question.
And so the first thing to always ask is, what did we actually do? What did we accomplish? You could also ask it as, what was the question about? So should we ask people for their feelings about what the question's really about?
I think in the interest of time, we probably have.
I could just, okay.
Yeah.
So you could say what we did is, well, at the very start of this question, we got a few simple functions, and then we basically defined addition. In part 3, the function f of a b actually gave us a plus b plus 1, but you could easily change it to just give you a plus b. And that worked for b positive. And then we also defined a function that does addition if b is negative or 0, so not positive. So we just took some simple functions and we defined functions that perform addition for any inputs, and we did that recursively. And like, not every question actually has to reflect something that like real people do. So stuff like, it can just be completely abstract. But if you think about programming a computer and teaching it to do arithmetic, the 3 functions at the top are the kind of instructions you could easily give a computer. It's just increment something by 1 in either direction, or choose between 2 things. And now we've taught our imaginary computer to do something more complicated, which is do arbitrary addition. So then we might think, well, how could we maybe build on this? So we've learned how to kind of define functions recursively. I think the first thing you should maybe think when looking at this question is, it's a little bit ugly that we can't just, well, so far we haven't just defined one function that does addition. We found one that does it for positive numbers, one that does it for negative numbers. That's like, it seems like we should be able to do it for just all inputs b. There should be a way to do that. And there is. So the first question you might ask yourself is, okay, how do I do that? Pamela, how fast do you want me to go into?
We're not going to be able to go through what the answers to these questions are right now in this webinar, but what we can do is pose the questions to you and get you to think about what those answers would be. But what I want you to learn from this whole thing is, the questions that Chris is asking now are the questions that he thought of after doing this question. And what I want you to get into the habit of, everybody, is what questions would you ask yourself to extend and further your understanding of what you've done in every single question. And you'll see from the kind of questions Chris asks, how much you can really get from a single question. So I'll let you continue, Chris.
Yeah, so we might also think, well, okay, we just did addition. Are there any other recursive functions we can define? Like, what are some plausible ones to start with? So while we did addition, maybe we could do subtraction. That seems like something to try. We could try multiplication. Another one that's interesting is like finding the maximum or minimum of A and B. You could use that, for instance, for ordering things, maybe, if you could teach your computer to do that. And then if you try those ones, maybe you can try some even harder stuff. So a couple of suggestions I thought of were, and this is something that could come up in another math question in a different form, or it's definitely the kind of thing you could be doing at uni. So one is, suppose, like we basically made a function f that applies +1 multiple times. So maybe we could make a function that applies some other function multiple times. So my next suggestion was, I think, this looks a bit complicated. It's just saying, let's take a and b to be positive just for ease. Can you make a function, suppose you're given a function h, can you apply that b times to the input a? Because if you can, that will make you make a load of recursive functions. This is just kind of what recursion is. So if you know you can do that in general, then that will let you make lots of other functions. Another thing you might try is, what's the maybe more complicated kinds of things you might ask a computer to do? Well, sometimes we ask computers to think about factoring numbers. So I was thinking maybe we could ask our computer, is B a factor of A, for instance? So that would correspond to making a function that basically, just for example, it sort of returns 1 if B is a factor of A and returns 0 otherwise. So that was kind of my last suggestion for something you could try to make. That one I think might be quite difficult if you try that, but it could well be worth doing. Yeah, and those are just some example ways to extend the question. Like, it's also worth yourself trying to think of similar extensions of your own, just like, what interests you. Can you actually do that with what you're given in this question?
Yes, your question is basically with the functions P, M, and S, how far can I go?
Yes.
What can we really make? Okay, great. Fantastic. So fast and fluent, we are going to be looking at timed practice, tricks for speed of calculation, and also a natural, well, fast and fluent is also a natural consequence of P, problem planning, R, reflective reflex, and O, outline organized. So if you're doing those other parts of prof really well, you will naturally get quicker. So let's have a look at 3 questions. Everyone have a quick look at this one. The question is, the graph of cos squared of x equals cos squared of y. Which of the following represents this graph? So have a think for like 10 seconds, and then Chris will go through what he would do in this question to kind of answer it quickly. All right, go for it, Chris.
Okay, so the key point, I think, is you don't want to just try and sketch this and then like compare it to the 5 options. You want to, I mean, we say often you can't do it by elimination, but in these graph type questions and multiple choice, that's when you do want to look at what the options actually are and then see which ones don't work. And then what are you looking for in the graphs? Well, you got to see how they differ. And what are the key properties of graphs that you can easily identify and then compare against the formula? So a couple of them that we're going to talk about are, firstly, symmetries. So this is something that's often useful. Looking at what the symmetries of the equation that tell you what the symmetries of the graph should be is useful for ruling some of these out. So our equation cos squared of x equals cos squared of y. What symmetries are you expecting the graph of that to have? Well, firstly, it doesn't matter if x is positive or negative. That doesn't change the answer. As in, like, if you put in -1 or +1 for x, it gives the same answer because it's put into cos and then that's squared anyway. So it should be symmetric in the x-axis, and likewise it's going to be symmetric. Likewise it's going to be symmetric in the y-axis. Actually, sorry, the other way around. It's symmetric in both axes. And actually, all of the graphs do have that property already. So they've been mean to you there. But there's one other symmetry as well, which is that if we take that equation and we swap x and y, it's actually the same equation. Like cos squared y equals cos squared x is the same as cos squared x equals cos squared y. So that means that the picture kind of has to treat x and y the same. You've got to be able to swap the axes and keep it the same. And that corresponds to having a symmetry in the line y equals x. And if we, well, do any of the graphs not have that symmetry? Yeah, the 2 on the left don't, so A and D. So we can rule those out. So actually, I've used this as an example of how you can use symmetries. You could actually do this just by looking at something else, which is our next point, which is intercepts. And intercepts are often a good place to start. So we've practiced with symmetries, but if you look at intercepts, you can see the graphs do have different x and y intercepts from each other. And if we look at our equation cos squared of x equals cos squared of y. Well, let's look for the intercepts with either the x or the y-axis. Let's do under the y-axis. So that means we're setting x equals 0. And that means we've got cos squared of y equals 1, because cos of 0 is 1. And that means we're looking for cos of y to be plus or minus 1. And what values of y work for that is going to be 0, and then pi, and then 2 pi, and then 3 pi, and then 4 pi, etc., and also for minus pi, etc. So expecting an intercept every pi, so an intercept at 0, which all of the remaining 3 graphs have, and then every pi from there on in. And that goes for the x-axis as well, because x and y are treated the same, it's symmetric. So it should be at 0 and then every pi. And if we look at B, the intercepts are too far apart, they're 2 pi apart. Well, probably the edges are cut off, but they're too far apart. And if we look at E, the intercepts, the distance between them kind of changes. Like they start off, the first one is far away from 0, and then the next one's closer, and then the next one's closer. And in particular, there is an intercept at x equals pi or y equals pi. So that means the only option is C, because that makes the intercept right. So that took me maybe a minute to explain, but that's something you could do very quickly. You think, okay, I'll look at the intercept. Oh, okay, this is the one that works. Just to quickly talk about some other things you could use. Firstly, well, yeah, to emphasize our trick, you don't always want to sketch from scratch. Sometimes you can just look at the important features of what the graph should, the important features the graph should have.
Yeah, and actually, when we're doing our assessments, students tell me this all the time. They're like, we haven't learned how to sketch that at school, and they're not expecting you to know how to sketch these graphs necessarily, but they will expect you to be able to eliminate ones which are incorrect for specific reasons.
Yeah. Yeah, just to note some other things you could look at. So periodicity. So that's kind of what we looked at with the intercept being every pi. So because cos has period 2 pi, it would at least, our graph should at least have period 2 pi in either direction. Actually, it turns out to be pi. Asymptotes, so these graphs don't have asymptotes, but another graph could have. And it makes it, yeah, if you can identify where an asymptote should be, that might tell you which graph it is. Where the graph is positive versus negative, so should it have a positive value here or not? Where it's increasing versus decreasing, so sometimes you can see what the gradient should be. Or whether it should increase or decrease. And likewise, I've put these two last because sometimes to find a gradient, you have to do a calculation, and that takes time. But you can also think about the turning points if you have an easy way to see where they should be. Yeah, should we move on to the next question? So this one, I'm not going to show you a whole solution because the fast and fluent point is just one trick you might do in the middle. So in this question, we're given two simultaneous equations, and they've both got like 2 to the x and 2 to the y in, and then the second one is 2 to the 2x and 2 to the 2y. And they like this kind of question. Hopefully you've seen this trick before, that you can basically do a substitution and say, okay, let's let u equals 2 to the x and v equals 2 to the y. And then we can rewrite our first equation as we've got u plus 3 times v equals 3. And 2 to the 2x is just 2 to the x all squared. So we've got u squared minus 9v squared equals 6. So what we're going to look at here is just what's the fastest way to solve this pair of simultaneous equations? What's the first step we should do? It's going to make it nice and quick for us. So the tempting thing might be, maybe I can rearrange equation 1, get, say, u in terms of v, plug that into the second one, get a quadratic in v, solve the quadratic, get a value for v, well, actually 2 values for v, either of which might work, and then get a value for u, maybe 2 values of u. And that's okay. You can see there are a few steps there. So I think a couple of people mentioned in the chat, maybe you can do difference of 2 squares. So, okay, let's try that. So Yeah, you can do difference of two squares. So in particular, equation 2, we can factorize as, if you just have this come up on the screen, it's u plus 3v times u minus 3v on the left-hand side. And that means we can kind of divide equation 2 by equation 1. So if we divide the left-hand sides, we're cancelling the u plus 3v, so we're just getting u minus 3v on there. And then the right-hand side is just 6 divided by 3, which is 2. So we get an expression for u minus 3v. And you might think, well, that's still got both variables in. We haven't eliminated either of them. But we really like it when we have simultaneous equations we can just add to eliminate one of the variables. And that's exactly what we have here. We've got u plus 3v and u minus 3v, and so we can easily solve for u and v now. So the trick here is basically reminding you, okay, always look for difference of two squares, even when it's not immediately obvious. Like if you look at the original question, maybe not immediately obvious, the second line is difference of two squares. But also, remember, you don't just have to solve simultaneous equations by substitution. You can add and subtract. You can also multiply or divide. Yeah, let's look at one more. So this is a kind of geometry type. It looks like a coordinate geometry type question. So we've got a circle, x squared plus y squared is 144. We've got a tangent that goes through the point 20, 0, so it's on the x-axis. And that crosses the positive y-axis. And we're asked, what's the value of y where the tangent meets the y-axis? So we mentioned before the importance of drawing diagrams. That was in the context of Dr. A, but it basically goes for all questions. You want to draw something if you can. What should we draw here? Well, it tells us about a circle and a tangent, so we might as well just draw those. That looks like this, that's fine. Is there any other stuff we want to draw? I think the key here is I'm going to be thinking of this as not a coordinate geometry question, so a question about equations of circles and lines, just a geometry question. I'm just going to draw some lines. So the first thing I'm going to do is, what do we actually ask for? We ask for the y coordinate where the tangent meets the y-axis. But that's just the same as a length in our picture. So if we have that come up, it's kind of it's basically the distance from the origin to where the tangent meets the axis. So that line. And then, okay, we've got a circle. It kind of looks like we've got a bit of a triangle with the tangent meeting the two axes. Do we want to add anything else? And the rules of geometry are basically, the rules of geometry questions in admissions tests are basically always draw a radius and always make a right angle. And here we can do both. So we draw a radius from the origin to the tangent, and we know that meets the tangent at a right angle. And we can also put on a length. So we see the radius of the circle is 12, and the distance to the end of the tangent is 20. And the next question is, well, we could do some calculations with these, but we've got some right angle triangles. We can maybe do Pythagoras. Can we go any quicker than that? Are these nice values in any special way? And maybe one person said it in the chat, which is, yeah, it's a 3, 4, 5 triangle, which they really like doing. There are other Pythagorean triples as well. Pythagorean triple meaning 3 integers, which would be the sides of a right angle triangle. But this one is basically 3, 4, 5, because the hypotenuse is 5 times 4. And one of the other sides is 3 times 4. So that means the third side must be 4 times 4, which is 16. We don't actually care about that length. What we care about is something else that's been said in the chat, which is these triangles are similar, because we want to talk about this line we put in bold. We want to find that length. And yeah, that little triangle, which is formed by the radius and that bolded length, that's similar to the triangle we just found all the sides of. So it's also 3, 4, 5. And if we look at which side corresponds to which, the 12, the radius, it actually corresponds to the 4 out of the 3, 4, 5 in that triangle. So that means the other sides have got to be 3 times, so this one's 4 times 3, the others have got to be 3 times 3 and 3 times 5. And in particular, the hypotenuse is 3 times 5 is 15. And now we read off the answer, which is B. So again, that's something you could do very quickly once you saw those couple of tricks. And it might take a bit longer if you had to work out the equation of the tangent and then where it meets the y-axis. You could just use Pythagoras as well, yeah. So just to summarize our tricks, it's always always try and draw a radius, always try and make a right angled triangle, and then look for things like similar triangles and Pythagorean triples. And these are kind of tricks we focus on when we're teaching our courses for these questions as well. If you want to know why they're similar, they're both right angled, and then the angle at the origin in the small triangle is the same at the angle at the far end in the big triangle. You could just chase through angles to see that works. But also, it's actually just worth memorizing this kind of pattern, that when you've got a triangle split like this, with a, so that radius is perpendicular to one of the sides of the big triangle.
Yeah.
It's a pattern you can remember.
I was just going to say, like, if this was theta, this would be like 90 minus theta, because that's 90 degrees, and then that would be theta again. So, you know, you can show that those two angles are the same. All right, well, brilliant. So that those are just again just a few examples of the types of tricks that we will be able to show you to help you get quicker at your work, and help you be able to spot quicker ways of doing things. And that was part of the Fast and Fluent. So exam techniques for Math, CTMUA and CSAT. So firstly, we've talked about today problem planning, identifying key information and starting points, and annotating your question and your diagrams. I just wanted to add, you can see we were underlining. Yes. It is actually good to underline, like we're doing it for a reason. Underlining, highlighting. I think you are allowed to highlight, if I'm not mistaken, although you shouldn't do it maybe in your actual work, but highlighting the question is probably not a problem at all. Timing. So, Chris, what did you want to say on this? So, firstly, you do know how much time you have for each question. We kind of covered that at the start. It is fine to, if you're taking too long, it is fine to leave questions and come back to them. Sometimes that does actually help. I think it's worth noting in things like the Mat Long questions, you aren't shown the marks for each part, but normally the end bits will take longer. So you've got to time them, taking that into account. Like, the bits to come are probably the hardest bits that will take you longest. It's also worth saying that, I think we're coming to this later, it's multiple choice. So it's part of the math is multiple choice, all of the CTMUA is multiple choice. You can guess if you have to, but you don't want to go into with that as a strategy. Like, do it at the end if you haven't answered the questions, but you don't want to plan to do that. If you have like 30 seconds left and you haven't got all the questions, do guess, is what I would say. Like, there's no reason not to. Yeah. So you don't lose marks for incorrect answers. By the way, in the CSAT, because they can see your solutions, it's worth just writing down. This actually also goes to the Mat Long questions. If you think you can see like a kind of plan for an answer, but you're not sure about all the details, you can quickly summarize your plan if you're absolutely short on time. And that could get you some marks. And in the CSAT, maybe it leads to an interesting conversation in your interview. Yeah, I don't know if any of our other panelists have any ideas on timing or other exam technique. Well, we've got some here. So draw a diagram as you're reading the question. I think that's a really, really easy one. Keep small factors. So basically you're saying, instead of writing a big number like 256, keep it as 16 squared. Sometimes that makes it easier to like cancel things. So just these are non-calculator tests, but sometimes you have to do a short calculation. So like little tricks like don't necessarily multiply everything else out at the start, like keep factors so you can maybe cancel them later. And then, yeah, we've talked about that one. Use size or special values for checking or educated guesses. And then, yeah, your non-calculated skills, I cannot stress this enough, have to be up to scratch. So you need to know your trig values, for example. You need to be able to calculate things easily. You need to be able to do fractions. I mean, all of these things, I know now that you have a calculator in your A levels, you may have forgotten how to do, which you shouldn't have, obviously. But you know, these are things that you really need to keep at the top of your mind. So what should you be doing between now and November to maximize your score? How early should you start? I would say start now, like start today. Let today be, if you haven't started already, let it be the start of your journey for your admissions test preparation. It is never too early to start. And you can see from what we've done today that even from one question, you can get so much. You can take a question, you can add your own bits to it, you can explore it, like take that time to explore. And we've been saying to a lot of our students, it's not about doing as many questions as possible. Well, it is important to do a lot of questions, but doing one question, and then if you get stuck, think about it, come back to it again, have a go again, come back to it again, keep trying it until like you've literally tried it 5 or 6 times and you're like, okay, I can't do it. At which point you can watch one of our video solutions, or you can get help from, you know, a tutor, or you can ask your teacher or whatever. So what I'm trying to say here is you will get faster by initially slowing down. So take your time with your problem solving. And like the analogy I like to give is, you know, when you go to the gym, you have to struggle, you have to work hard to get stronger. In the same way with a question, you have to struggle with it in order to improve your problem solving abilities. So going and looking at the solution straight away really isn't the answer, and actually spending time on the problems is what's going to help you improve. So therefore, it is never too early to start now, and feel free to then spend a good amount of time on the questions in order to improve.
I'd also just add, you don't have to know which degree you're applying for. Like doing any of the admissions tests as practice is good problem-solving practice.
Exactly. So, for example, if you weren't sure between Oxford Maths and Cambridge Maths, and you ended up choosing Cambridge, you won't have lost by doing math papers. They will be really useful to help you start thinking like a mathematician. Past papers, yes, of course, do as many past papers, as many questions as you can. And as Chris just said, use other tests. So if you're doing one, feel free to do the other as practice. And then as you get closer and closer to the time, do time mocks. So I'm saying initially, spend that time to improve your problem solving brain. But then as you get closer to the exam, you need to see what you can do in time conditions, because it might be that you're amazing when you spend 6 hours on a paper, but when you only have 2.5, you don't get many marks. You need to be aware of that. What I recommend, though, is not just doing a time paper and then marking it. Do a time paper in one colored pen, but then carry on doing the paper in another colored pen. And when you do end up marking it, you can at least see what you got in time conditions, but you don't ruin that opportunity for yourself to actually think about the problem further. And then, as you can see here, reflecting on previous questions, you saw what we did today. Do that, and say you've done a question a month ago, go back and see, like, okay, what did I remember from what I did here? There's absolutely no harm in revisiting those questions. And then after you have finished a question, look back at it and try and figure out, like, did I actually do it in the most efficient way, or was there a better way that I could have tackled this? All right, then let's quickly get started with the Q&A. So okay, somebody says, hi, do we not have to sit the step? So Chris, could you just talk about the step and what that's used for?
Yeah, so although it's used by other unis as well, it's basically set by Cambridge. The way it works for Cambridge is you apply, maybe you're invited to interview, maybe you get an offer. If you get an offer, then the offer will include a step grade. You take the step at the same time as your A-levels. And then if you get the grades, then you get your place at Cambridge. And there were a couple of step papers. Confusingly, now there used to be 1, 2, and 3. They're not using 1 anymore. So now there's 2 papers, but they're called 2 and 3. You have to do both for Cambridge. For other universities, they might just ask you for a certain grade in any step paper, or for a particular grade in a particular step paper. So, for instance, Imperial asks for a step for some computer science degrees. Warwick I think allows it for maths. So basically you can get away with lower A-level grades if you get your step score for Warwick. And other universities use it in a similar way to Warwick, or have done in the past, at least.
So I'm just going to quickly put in the chat our past webinar on STEP. So if anybody wants to kind of find out more about the STEP, there's a lot in that webinar, and I've just put it in the chat right now. So
it might just be worth saying, like, we do advise maybe if you're preparing for STEP at this time, maybe you'd start with math and then work towards STEP, because STEP covers, like, it's taken later, so it covers more material and it's harder.
It's definitely.
So,
yeah, absolutely. Okay, let's move on. So for Warwick Maths, do you have to take the math and the TMUA? You don't have to, but you could get a lower offer if you do take them, if you do well in them. So yeah, it's worth doing. Okay. So somebody says, will the interviews be conducted online this year? And if so, how will the CSAT be used, since it's normally administered at interview? So maybe I'll ask, I don't know if Sebastian or Agnideepa, do you know how our interview tests were done at Cambridge this year? Or in the last year? I'm thinking actually things might open up by this year, but in case things are online, do you know how that was conducted?
Yes, CSAT is actually, I think it was a 3-hour exam, so they actually changed the format this year. And I think they had half an hour to upload their answers. So it was conducted, everybody who had an interview invitation wrote the CSAT about a week before their interview.
Okay.
And I think everyone writes a CSAT, regardless of the college they apply to. Some colleges just won't use them.
No, it used to be the case that all of them asked for it, but I think now it's changed. So I think maybe when you applied, it probably was all of the colleges, but now it's just the CTMUA that everybody has to sit. So it's not necessary that you would be asked for it at your college, I believe. So, okay, hopefully that answers that one. STEP webinar, yeah, we've already got that one in the chat. Okay, hi, for the Trinity College interviews, it's only about doing CSAT and discussing these questions with the examiner, or are there other parts or sections? Oh, I don't know. I don't know if anybody knows specifically about Trinity.
I know someone who was given an interview test at Trinity for
Maths?
Was it maths or was it for natural sciences? I can't remember. But they were given the test beforehand, and they were basically told your interview will be on these questions. That was the instructions they were given. However, the interviewers can do whatever they want. And like, it might just depend on the time, or like how well you already did the test, or like just what they want to ask you about. So they can ask whatever. They do give you instructions in advance, but not very far in advance.
Yeah, I think that's the thing about interviews. It's kind of on the interviewer's whim. Like there's no real sort of regulations of what they can and can't ask. So it might not just be based on the test. And somebody has just put in the chat here, interviews took place at least a week before interview, and Cambridge interviews are going to be online again this year. That's what somebody's saying in the chat. So it's worth, I'm not really sure, but I trust you. But anyway, everyone should just double check. Will we be able to use calculators in the tests? The answer is no. Do we know the total marks? Yes, you know the total marks for the questions in, for example, the math paper. It's 20 marks for the longer questions, or is it 15? It's 15 marks for the longer questions and 4 marks for the short questions. Is CTMUA the same as the TMUA? Yes, they are exactly the same test. But the one that, well, when Cambridge adopted it, they put the C in front to make it Cambridge Test of Mathematics for University Admissions. Can any further maths concepts appear in any of these exams? Sebastian, why don't you talk about the MAT? So are there any further maths concepts tested in the MAT?
No, so it's only A-level content in the MAT, first year A-level, and I think they can do some first term year 13 A-level stuff, but no further maths, because I mean, it's not even technically a requirement to have further maths. So.
Yeah. Okay. What about for STEP? Agnideepa, for CTMUA or CSAT, like, can you think of anything? Yeah.
Sorry, whether A-level further maths concepts are. I didn't do A-level, so I wouldn't be able to answer that.
Okay, fine.
I know they had a matrix question in the CSAT a couple of years ago, so
Okay.
it can happen.
That's the first maths topic. I think if there's any one topic that I would say it's worth knowing really well, because it would be helpful for your like thinking as well as how you might lay out a proof, might be proof by induction. I don't know, Chris, if that would help?
That's actually required almost for the CSAT.
Yeah, exactly. So proof by induction also for STEP. Well, I know step 1 doesn't exist anymore, but if you are practicing STEP papers, then in step 1, they used to say like, it's basically based on A-level maths, but there are some exceptions, and proof by induction is one of those main exceptions. So that's a really useful thing to know. Somebody's asking how detailed you have to be when they say explain. Hopefully we have covered that in, so they gave the example of one that we had earlier, and let's kind of do that. We'll answer all the questions, ideally speaking, if possible. Okay, then somebody says in A-levels, extra time is given to some students. Is that taken into account? Yes, you get the same amount of extra time in your admissions test as you would normally. So if you get 25% or 50% extra time, you get 25% or 50% in your admissions tests. Does the IB maths analysis higher level cover the same amount as the A-level content that would be covered in the math test? So I have to admit, I'm not fully familiar with the high level. However, if you think about it, like high level is normally one, like IB is one of 6 subjects, and A level is normally one of 3 or 4. So for that reason alone, the IB doesn't cover as much content as the A level. So certainly for something like STEP or CSAT, I don't think you would have covered enough content, and you would need to learn a few topics on your own. For MAT, there is a chance you could have covered everything, but it would be a case of looking at those individual topics and seeing if you had covered them. I don't know if anyone has any further comments.
So you probably want to do that for the sake of your interviews anyway. I mean, they know you're taking the IB, but it's easier if you've studied the same material as the other candidate.
Yeah, that's true. Yeah, you probably do want to have a look at some of the A-level material. Anyway, do GCSE grades actually matter when applying to Oxbridge? Sebastian, any ideas for that one?
Yes, they do. It depends on the college, the subject and everything. I know my friend doing physics at Brasenose, he got a whole sheet back about how they calculated a score based on GCSEs, which they then use that in collaboration with other things to decide whether to give an offer. So they do matter, but obviously it's not the be all end all.
Okay, brilliant. Thank you very much, Sebastian. Is difficulty always increasing down the question? Is another question that we have.
Occasionally you get like a short last part.
But you normally have had to be able to do the bits before that in order to...
Yeah, it would be some like short extension of the previous bit, which is the hardest bit. Yeah.
I think maybe one other useful thing to mention as well is even if you didn't get a part, if it says prove this, then you can still use the result in a next question, even if you couldn't do it. So
yeah, that's a really, really valid point. Even at A-level, you can do that. That's often why they give show like questions, so that you don't lose like the whole question if you couldn't do all of it. Would we get credit if you mentioned what G of AB you tried, as Chris has done?
I think they're saying because I showed like a first try and then a second try.
Ah, okay.
I don't think there'd be marks specifically for that. Like, if you got the right answer straight away, then that's even better. It could be that the marks are split up. They don't release mark schemes, or do they now? There aren't mark schemes for lots of math papers, but it could be there's a mark for getting some part of the function right and not another. So if you like try it and it doesn't quite work, you could still get some marks from it.
Okay, perfect. All right, so somebody says they're not sure what was meant by the recursive step. Could you explain it?
So when we had that recursive function definition, there were basically 2 cases. One where you end up applying the function again, just applied to a different input, and another one where it just stops. And the recursive step was the first one where you you're applying the function one more time.
Okay, and somebody else is asking about recursive. So they said, is this recursive stuff in the mat something that we will cover in year 12 or 13, or is it something I meant to learn outside of school? I'm in year 12 and we haven't seen anything like this as far as I'm aware. Thank you. Could Agnideepa or Sebastian comment on that? I think maybe if you stay unmuted and just speak, it would be great.
Again, the question being, is this covered in the...
So it's not. I don't think the simple answer is no, it's not covered in the A level.
Right.
But
In maths A level.
yes.
So what's the question then?
So is it, well, I guess if you did A level, which may be more applicable to you, Sebastian, like how did you kind of go about tackling those questions?
I mean, I guess I kind of, because I'd done a lot of my own reading around the subject, I don't think that was really an issue I faced. I think by the time it comes to any of the kind of MAT, CSAT, CTMUA, you probably will have seen everything they have, unless it's something they're kind of introducing that's new, in which case they'll explain it properly. So it kind of, if you do proper preparation now, I don't think that's something you have to worry about too much. I guess in terms of when you're actually in the exam, just don't panic if you see a new concept and just kind of try and really understand it and then go for the questions.
Yeah, for the CSAT, I'd like to say if you have A-level computer science, then you've definitely seen recursion. But if you don't, if you've done GCSE computing, I hope you've seen recursion. The Fibonacci function is the Fibonacci numbers, great example of recursion to familiarize yourself with the concept, because it is something that will crop up again and again in these exams.
Yeah, think about it. At A level, you will have seen recurrence relationships, and they are also recursion. It just might not be introduced under that name. But yeah, you'd only see it systematically in computer science, I think.
I think the whole idea here is that something is related to the thing before it, which is related to the thing before it. So if you've ever seen something like that, and even if you haven't, I think it's quite an easy concept to kind of grasp if you think about it enough. So somebody is saying, we mentioned colleges at the start, and they were wondering if there's a chance for a brief bit on how we chose our colleges. So who would like to go first on that one? Agnideepa?
Okay, so I've finished doing Comsci at Churchill. And so how I chose my colleges, I wasn't being super strategic, which may not have been a great decision. But I went to the admission statistics website. I know there's one for Cambridge, and I assume there's another one for Oxford. And so there you see the number of applicants that get in that apply for each subject, each for the last 5 years or something, and how many of them get offers, how many get pooled. And so if you're relatively confident in your abilities, you might want to apply to a college where a lot of people apply for that subject, because that's generally an indicator that that college will be quite good at that subject. Alternatively, you might look at the current number of students in that course at that particular college, because colleges with a larger number of students doing a particular course will have way more resources, and it scales up. So they might have one teacher for a particular subject. For if they have 15 students, it makes economic sense for them to bring experts in to explain concepts to you. So if you're relatively confident in your abilities, I would suggest going for a college with a large number of students doing your course. Otherwise, you might go for, if you're not confident about the CSAT, for example, you might just want to do the CTMUA and go for a college that doesn't use the CSAT. It'll depend on where your strengths lie.
Okay, Sebastian, what about you?
I also looked at admission statistics, which wasn't really the best plan because it varies so much year by year that, with the exception of something like Trinity College, Cambridge for maths, then it's kind of, it doesn't make a huge difference to your teaching which college you go to, and it doesn't make a huge difference to your chance going in. So I think that's not what I should have looked at. What I would have looked at if I knew better was things like, if you want, say, if you want to be guaranteed accommodation in college the whole time, that's a big thing to look at. If you want to be guaranteed things like a kitchen your whole time, that's something to look at. Multi-faith prayer rooms, the grounds they have in college, all these kind of things. I think that's the important stuff to look at, in my opinion.
Location as well, I think, but it's
Yeah,
close
true.
to your department.
Yeah, exactly. How far away it is from your faculty? Well, for me, it was important because I didn't have a bike in my first year, so I wanted my college to be quite close to the maths department. I also wanted it to be quite close to the center of town because I don't really like having to like walk far for shops and stuff like that. And yeah, number of years of accommodation. So number of years in college accommodation or college owned accommodation is also an important factor. For some people, it could be like dietary requirements. So all of these are factors that you can look at to, if you're very sporty, do they have sports grounds? You will know the things that are kind of important to you. And I think that's the best way to make the decision because as we've said already, admission statistics vary year on year. And actually, if there is a college which has, you might be tactical and say, okay, well, this college didn't have many apply last year. Maybe I've got a better chance of getting in there. Then maybe everybody else is doing the same in this year. It's going to be super oversubscribed. And also Oxford and Cambridge have a pooling system. So if you apply to a college that is oversubscribed, happens to be very oversubscribed that year, but you're a really good candidate, then another college could take you and interview you there. Or they might offer, re-interview you there again I think Cambridge has a summer and winter pool, and at Oxford, they interview at multiple colleges anyway. So Chris, any further things to add on how you chose your college?
I think I mostly chose based on the food, as in it was cheap and plentiful, including on the open day. The only thing I'd say is, so I didn't think about this when I applied to my college. I don't actually know how it would have influenced my choice in retrospect. I was the only person admitted for my course in my year. And actually, no one was admitted the year before, and 2 or 3 the year before that. So basically, I was doing maths and philosophy. There weren't many people at my college, which was Merton, doing that degree at that time. I don't know what it's like now. And you might like that or you might not. So there were other mathematicians, so I could discuss a lot of stuff with them. Some people, I think, like it depends how important it is to you to have a group of people who are doing the same subject as you, who is easy to get to know. You can meet the other people at other colleges on your course, but it's kind of easier if they're at the same college. So you could think about how much that matters to you. Do you want to go to a college with lots of people on your course? If you're doing computer science or philosophy, it's basically impossible. You're always going to be the only person in your year. But yeah, it's another thing to bear in mind.
Okay, yeah, brilliant. And what you should all be aware of is on our YouTube channel, if you type in the Oxbridge formula into YouTube, we've actually just created like videos of people from every single Oxbridge college, or undergraduate college, I should say, talking about their colleges, college life, how to choose college, etc., etc., etc. So that will be a very, very useful resource. So highly, highly recommend that one. Right, let's keep looking at the questions then. So somebody says, I'm considering computer science at Cambridge and at Imperial, but would this mean having to sit both CTMUA and the MAT? Would you recommend switching to apply to Oxford instead? What do people think?
Computer science and Imperial.
Computer science at Cambridge and Imperial. Oh, well, if you do computer science at Imperial, mostly I think they ask for the step, if I'm not mistaken.
I would need to check again this year. I didn't think they were asking for the MAT, but that could be out of date. If they are asking for both, it is a bit inconvenient because they're on the same day. So
then again, I think, when you have clashes for A-level, they just quarantine you. Sorry, it's a really bad word to use now. But anyway, so you do one exam in the morning and then, you'll be with a teacher, they supervise you, and then you do another one in the afternoon. And so if you could sit them both in the same day, in a way, you're giving yourself 2 chances, because if you prepare for one, you're almost prepared for the other one. They've got quite similar content. The CTMUA does have that proof and logic bit, which, to be honest, is really useful for your degrees. It's worth doing. And then if one didn't go so well, at least you have a second chance, in a way. So I think there are advantages to doing both. I don't know what.
I suppose I just wonder if I was like dead set on Cambridge and Imperial was my second choice, and then the math is earlier in the day, then you're kind of tired when you come to the CTMUA.
Hopefully you could talk to your examination officer and say which one you wanted to do first, though.
Yeah, that's always a good idea. Yeah.
Yeah. Any other thoughts on that one?
I think since the preparation for these would involve the same skill set, if not, even though they don't have the same format, I think you should choose whichever course appeals to you more.
Yeah. Okay, great. Right, there are lots more questions. Before we go through those, just wanted to quickly remind you that you can book a consultation with us. oxbridgeformula.co.uk/mm-consultation. You can scan this QR code. We have got this new Maximise Your Summer bundle available. So do get yourself booked on a call. We've had, I think, maybe 14, 15 people book on today. So yeah, loads of interest and only limited spaces, in fact. So if you are interested and you want to find out more, then make sure you get yourself booked onto one of those. Right. Then,
currently Imperial is saying the same as last year, which is that you do a separate short online test for computer science, which isn't public. It's just like a private thing that Imperial does online. But they're not suggesting you do the math at the moment, as far as I can see.
But we do know a lot of people that have been asked for the STEP. So STEP is something is asked frequently. So what does the F in the prof methodology stand for, Chris?
Fast and fluent.
Yeah, so the idea is that we're teaching you how to become quicker at doing questions as well as how to think about planning them. So that's what the fast and fluent bit is. Is there any prospect on being granted these slides? We will be giving you we'll give you the opportunity to get a recording of this webinar. So we'll let you know how to do that in just a few minutes. But we won't be giving the slides, but you can obviously go through the video and find the bits you're looking for. Can the CTMUA CSAT be used to prepare for the MAT? Yeah, I definitely think that all of them are useful for each other. So math is maths at the end of the day. If you're getting good at maths and problem solving, then they're all going to help you with each of the other ones. Is it possible to sign up for the STEP courses without the full mastermind? I strongly recommend booking, if you're interested in asking stuff like that, book a consultation and we can see what we can do. So that's the easiest way, because it will be difficult to answer all these questions individually. So yeah, get yourself booked in. For the MAT, it says on the website what the average successful score is, but where can we find out what a good score is for the CTMUA and the CSAT? Great question. So for the CTMUA, it's actually a scaled. It's like they have like a scale. Actually, one thing I highly recommend. We mentioned it at the beginning. Our book, The Oxbridge Formula. In there, we have an example of a scale. What do you call it? Like a standardization sort of scale, where when they standardize it, they're asking you to get like a 6.0 or above to count as a good score. And then we show you what that correlates to in terms of number of questions that you get correct. So yeah, that's how they do it. CSAT is, it's marked in college. It's not a public exam, so it's a bit more tricky. Agnideepa, did you find out about, or do you know of anyone that found out about their CSAT score? Or...
No, but I can kind of give some anecdotal evidence. Churchill and Trinity are kind of the biggest colleges in Cambridge for computer science, and Trinity uses the CSAT and Churchill does not. And my director of studies, the person who is mainly involved in deciding whether to admit you for the course at a particular college, you will almost certainly interview with them. The director of studies for computer science at my college doesn't look at the CSAT at all. We were all made to I sat an overseas admissions test, but my peers were made to sit the CSAT, but it wasn't counted at all. So really, it's college specific, and the college also provides a different weighting, and what's a good score for one college. It might depend on what questions you've answered, or they will mark it very differently.
Yeah, so I want to caveat that with, remember when Agnideepa said it, the CSAT was like a compulsory Cambridge wide thing, and it sounds like some interviewers took it more seriously than others. However, now only 5 colleges are offering it, so presumably, if you go to a college which asks for the CSAT, they are going to care about it. That, I think it's important to caveat that with not, oh, they're making me do the CSAT, but they're not even going to look at it. No, they are going to look at it, and it's going to be a valuable part of their process of kind of evaluating you and assessing you. But yeah, I think with all of the tests that you do at interview, it's very subjective. They might just be comparing you against each other. There's no such thing as a good score, if that makes sense.
I was just going to say about the CSAT, what matters more is, in a sense, how interesting your solutions are, because they see your script. So it's whether you show you're thinking about things in an interesting way and not like the numerical mark you get. But obviously it's good to get questions right.
That's true. Yes, that's very true. So it's like they're going to use what you did as a basis of discussion. So even if you'd got something wrong, but then when you talk about it, you understand your mistake and you can explain it better, then that's absolutely fine, I think.
I'm worried that sounds like you just want to write interesting stuff that's not to do with the question. No, you meant to solve the question, and I just mean like it's how good your attempt is that matters.
And also, obviously, the thinking that you do during that test. During the test is going to make you better at the interview, if you think about it well.
But I believe this also goes for the MAT, that they can see your script.
Right.
So same principle applies.
I don't know. I don't think the same principle applies. They're definitely
not quite not to the same extent, because your numerical score matters a lot more.
Matters a lot, I would say. But when somebody asks for, for Trinity College's interview, it's only about doing CSAT and discussing this question. Oh, we already answered that one. Are there any maths books to help me familiarize myself with these specific types of questions? Agnideepa or Sebastian, if you have any suggestions.
Yeah, my main suggestion would just be Advanced Problem in Mathematics by Stephen Siklos. Is a very good book, probably the best for university admissions. It definitely does a bit more than you would need for something like the MAT, but that's not exactly an issue to be over-prepared. So that's my main recommendation.
And you can download that book on our website. So if you go to stepmaths.co.uk and go to free resources at the top, you can download the Stephen Siklos booklet there. So feel free to make use of that resource. And then Agnideepa, you were going to say?
I actually was going to recommend that very book.
Anything else? Any other books that you can think of?
I used completely different curriculum for my preparation. So for the CSAT, if anybody is looking for guidebooks or preparation material, I would suggest, once you're done looking through past papers, because the CSAT is actually based on Chomsky logic. It's based on the skills that you need to be a good computer scientist. I'd suggest going on HackerRank and looking at some of the easy or medium questions and trying to figure out the recurrence relations, because coming up with recurrence relations is something that's pretty important in the CSAT.
Okay, do you mind putting the name of that resource into the chat, Agnideepa? That'd be really helpful. Somebody has very kindly says, I don't know about you, but the Oxbridge formula book is very useful. That's very kind of you. I mean, it is a very useful book, see us. And it also has this book here does also have suggestions of other books you can read for your maths application, your computer science application, which we don't really have time to go into too much detail, but I think there's probably 20 suggestions there in this book.
So some suggestions are kind of reading from maybe your personal statements. So you've got to distinguish between things that actually have problems in that are useful practice and things that are like demonstrate passion from the fact you're reading about them but aren't actually giving you practice questions. I'd also say, like, we list there are sort of bridging books. I think maybe the start of some of them could be good for some of the more abstract questions, because it shows you the difference between uni maths and and A-level maths.
Good stuff. Somebody says how not to be wrong is brilliant in my opinion. Okay, great. Thank you, Agnedeepa, for adding that. I think you've only sent it to us actually. If you also send it to the attendees, that would be great.
Oh,
I just want to
right. Sorry.
Somebody says, I've just finished year 11. Is it too early to start the course? No, you can book a call with us now, and we have options that you can sign up to right now. So do feel free to book even if you're in year 11 or you've just finished with GCSEs. Do workings carry weight in the MAT test? Yes, they do. In CSAT and MAT and the long questions, yeah, they do. In the CTMUA, they don't. How do you decide whether to do computer science or a joint maths and computer science degree? Sebastian, that's for you.
Yes, so I actually originally applied for maths, and then halfway through my first term decided computer science looked interesting, so I switched to maths and computer science. How would you decide? I mean, I suppose it just depends how much you like maths versus how much you like computer science. I think maths and computer science at Oxford, it's a really nice kind of combination of the computer science modules and the maths modules. You kind of get the good foundation in both. So I do think it's a really good degree. I'd say, I mean, there's not too much specific advice I can give to decide. It's just how much you enjoy maths. I guess one thing I could also add is the maths modules you do are almost all pure if you do maths and computer science. So if you like pure maths, then maths and computer science is definitely a good degree.
And I don't think the course is offered anymore at Cambridge, so I don't think it's possible to take maths with computer science at Cambridge anymore.
Okay, perfect. Thank you very much. So which one is better to get into Oxbridge, A-level or IB? My school offers both, but has a bigger reputation for IB. I would say if you're applying for a mathematical subject, A-levels, because you have A-level maths and A-level further maths. IB doesn't have a further maths, and you're doing one of 6 subjects, as you already mentioned, whereas here you could be doing 50% of your A-levels as maths, or even, you know, 2/3 of your A-levels, 66, 67% of your A-levels as maths. So you're going to have a lot more exposure to it than you would if you were doing something like the IB, which means that when you get to university, or well, firstly for your admissions test, you'll be more prepared. Secondly, when you get to university, you'll have done more, so you'll find the course easier. I don't know if anybody has any further opinions on that.
I basically agree. Yeah, you want to do further maths A-level. And like, maybe it's getting better, but some people have in the past complained about the grade boundaries for IB being too high relative for A-level. I suspect it's something that Oxbridge are working on, but it is something that's been a problem in the past.
Somebody wrote in the chat, I think CTMU has been removed, so Cambridge computer science scientists will sit the TMUA, but they are literally the same paper. Like the TMUA and CTMUA are the same thing. Somebody just put that in the chat just now. Any more on the IB versus A-level question? Nope. All right, good stuff. Somebody says, I'm currently a grade B student at A-level, but I really enjoy all my subjects and I'm aspiring to go to Oxford to study computer science. What are the most effective ways to boost my grades so that I can be in with a chance of success?
I'm not sure which.
Yeah, well, actually, that's a very good question. What subject are you a B grade student in right now? So if you could let us know that, what subjects you do, maybe we can offer you some more help. Which admissions test is best to choose from? Again, that's quite a vague question. What subject are you applying for? You can't always choose. It's kind of dependent on which course you apply to. So if you give me more information on that one, we can help you. For the CTMUA and the MAT, when, if ever, do we get a mark? So yes, for CTMUA, you get your mark before your interview, I've heard, at least your standardized score. And for MAT,
I think that's about a month or so after your interviews.
Yeah.
If I remember correctly.
So I guess you find out whether you got in mid-January. You find out whether you got an offer, I guess. And then after that, you can, is it that you have to ask for it? Did you get given it?
No. I got the MAT score back just automatically. I think they'll probably do that again this year.
Okay, perfect. Guys, I just want to remind you, if you have Q&A questions, can they go in the Q&A and not in the chat, please? Fantastic. If the uni asks for a good grade on either Math, CTMUA or STEP, which should I choose? That's a good point. I mean, STEP is taken at the end. So if you didn't do well on the Math or the CTMUA, you also have that second option of doing STEP. But don't think it's not an easy option. STEP is really hard. Yeah, go on.
Normally, when we say a good grade, normally you're getting that offer from, say, Warwick after you've taken the Math or TMUA already. So you maybe have the choice whether to do STEP as well if you already took one of the other two. But it's not like, I mean, you can only sit Math or TMUA once when everyone sits them at the start of November. And I suppose it's possible Warwick could give out an offer before that, but I don't think it's normal for them to ask people to take those tests beforehand. I could be wrong. Yeah.
There's a question on the chat that I think is quite relevant.
Okay.
I think it asks, how far does A-level ComSci contribute to further education in university? Because I didn't take ComSci right now, but I do intend to take it as my degree. I think so. It doesn't matter. The most important, at least for Cambridge, the most important thing for computer science is that you're good at maths. So maths and further maths are far more important than A-level computing or computer science, and that's actually official advice from the colleges. And in your first year, it is a great equalizer, so they will make sure that everybody is up to speed on the concepts that you need to learn.
Yeah, I agree with that as well. I'd say also definitely try and practice some programming if you can, because at least at Oxford, they don't exactly choose the easiest programming languages. So if you go in without any knowledge, yeah, I think it would be pretty difficult, but definitely still possible.
Okay, awesome. Where can we find the CTMUA or the TMUA papers? I've had difficulty finding official resources. Actually, if you go to our website, which is stepmaths.co.uk or oxbridgeformula.co.uk, in the menu bar, you'll see past papers tab, and you can find all the past papers there. Are there any other resources you can recommend to practice for admissions tests? So we've already had a few, right? So we talked about this HackerRank, Leet Code. There's another one called Project Euler, I think is quite a good one. Then Enrich, like just UKMT questions, BMO questions, and obviously, as we've already mentioned, all of the other tests would be good resources. Anyone have anything else to add?
I mean, you can find, obviously this is more for interview, but you can find a lot of maths interview questions that would definitely help as well. You can literally just search like Oxbridge maths interview questions and you can find hundreds. So those would help as well.
Brilliant, thank you. Somebody says, I got a silver in my UKMT competition. Is it worth mentioning it in my personal statement?
I personally don't think it's worth mentioning Maths Challenge unless you made it into the Olympiad, because it's just kind of a thing that everyone does. I mean, it's not exactly going to hurt your application, but it doesn't kind of show. I just think it's a bit of a waste of words, to be honest. But
yeah, I think in a way, remember what we said about the personal statement not being a really important factor in your Oxbridge application. So in a way, like whether you do or don't put it, it doesn't really matter too much. But I would say if you had got, I think as Sebastian was saying, the higher you go in the UKMT sort of competitions, the more like impressive or it would look or it would be. So the more it would differentiate you if if you got into a higher stage of competition. Any more comments on that one?
I just like to agree with you on the personal statement isn't that important. So,
okay. Somebody says, do you get full marks for the correct answer? Now, it's a bit vague as well. Do you mean the correct, just literal answer or the working? Because if you, for example, have a show that question, then getting the answer is going to give you 0 marks without any working. So I don't know if anyone else wants to add anything to that.
Well, I will say it does. Like if you use a different method to the one they were expecting, and it doesn't tell you what method to use, then yeah, you get the marks. But you do need to explain. If it says explain, justify, if it says justify, etc.
I know, yeah, for the MAT, it's very much based on workings. I think I've even heard that you can still get full marks if you made one sort of small algebraic error at the end, if all the working is kind of coherent and stuff. So it definitely make sure you're putting the workings.
Okay, fantastic. What supercurriculars revolving around computer science can I do in the summer to make me a strong applicant?
I'd suggest knowing the concepts of if you plan on doing programming, then suggest taking a language and really trying to get into the concepts associated with that language. Like for example, if you know Java, then figure out where does the inheritance thing break down? What can you not do with the concepts? Why are those barriers there? What can you not do with your programs? Like, why are the languages designed the way they are? I don't think supercurriculars help too much with, and they don't matter too much, so definitely don't prioritize them over exam prep. But if you have time, you can try and make an app or a website just to familiarize yourself with programming and projects, but don't prioritize it over any tests, is my advice.
Yeah, I completely agree. And I think do supercurriculars to make yourself better at computer science rather than to make yourself a stronger application, because in the end, that only goes on the personal statement, which they don't mind too much about. So.
Is there a particular, say, language or kind of programming task that is especially useful to have practiced before you start uni?
So at Cambridge, and I don't know what it's like for Oxford, but at Cambridge, the strongest students at the beginning of first year, and as I've said, first year is a great equalizer, so don't worry too much. The strongest students tend to be the ones that are good at informatics. So the informatics Olympiad questions, those are really important. And so often many of these students will have been trained in the informatics Olympiads, and they tend to know a lot of algorithms, and recursion and all those things comes very naturally to them. So I'd say programming language, either Java or C++, to learn, and programming tasks, definitely algorithmic problems or informatics Olympiad problems.
Right.
Yeah, I'd say I pretty much agree completely with that for Oxford as well. So.
Wonderful. Thank you very much. Quick reminder, guys, if you have found today useful and you think you could sort of benefit from learning from somebody who's really good at answering these problems, then get yourself booked into a consultation, oxbridgeformula.co.uk/mm-consultation. So somebody says, for dual honours, say maths, computer science and philosophy at Oxford, do you have to do a philosophy admissions test on top of the maths admissions test?
No. So computer science and philosophy, maths and philosophy, maths and computer science, maths and statistics, they all do the MAT.
Yeah, pretty much.
You might be able to find a philosophy admissions test, but I think it's just for theology and philosophy, so you won't have to do that. All
right. So if I apply to both Cambridge and Imperial, do I just do one TMUA or for two of them, don't I? Yes. So if you're applying to Cambridge, then you need, well, you don't need the TMUA for Imperial computer science. But if you were applying for, it's a bit complex, but I don't think you would, you wouldn't need the TMUA for Imperial at all, I don't think. I want to do a pure maths degree, and the uni is asking for a good, we've already discussed that one, sorry. I'm around 4Bs for maths, further maths, computer science, and physics. So the person that asked before. Well, really, the first thing I would say, okay, how can you boost your A-level score? I mean, just doing loads of questions, and actually loads of what we've discussed today could be really helpful. So it's like rewriting the question, and like in words, understanding what it's actually trying to ask you, getting stuff learned off by heart, like trig formulas, trig equations, trig formulas as well. Try not to be reliant on your formula booklet, because that will force you to understand the ideas. I don't know if anyone else has any sort of tips for improving your A-level score.
Saying this as someone who did lots of A levels, you are allowed to drop one. If the problem is the workload, then you can drop one, but don't drop further maths. Yeah, they might. I was just going to say, it might also depend on whether they're being taught maths and further maths at the same time or one after the other. Because I think the first way, maybe you would struggle more at the beginning, but stuff comes together later, because it's maybe easier once you've seen all the topics. I don't 100% know.
Yeah, I'd say computer science and physics A-level are both very knowledge-based, so it's mainly just about revising, really, to get your grades up. And maths and further maths, yeah, it's just about practicing a lot, I think.
Hey, somebody is writing in the chat here, presumably a teacher, to boost grades, I don't know, attending all lessons, getting enough sleep so you can engage fully, putting more time into the three key subjects, and less gaming, is what is being said here. Okay, great, thank you for that comment. Right, can you do the TMUA when applying for maths at Oxford as well as the MAT? Would it be helpful? You can't just do the TMUA for Oxford. It doesn't count for Oxford. For Oxford, you have to do the MAT. You can still sit it. It will be helpful for your other unis, but it won't be helpful for Oxford.
You might have to pay. I don't know. Like normally your school would cover the cost, but I don't actually know if there's an.
If you had to sit it, your school would cover the cost. But if you didn't have to, you might have to pay.
Yeah, it's for fun, and
like I did step for fun, and I had to pay extra for it. Okay, cool. So what A-levels did you all take, and what degrees did you all do afterwards? So Agnideepa, did you do A-levels or?
No, I'm from India, so I did, but I did maths, physics, computer science, chemistry. Those are the key subjects that I did. And so I didn't have any maths versus further maths divide, so my syllabus covered both maths and further maths. And I went on to do ComSci at Cambridge.
Okay, Sebastian?
Yeah, so I did maths, further maths, physics, and computer science A-level. And then, as I said, I do maths and computer science now.
Chris?
So like, okay, so I did 6 A-levels.
Really clever. He did loads of A-levels.
No, it's not like, it's not, I don't know, it was by accident. I did maths, further maths, physics, English, history, and Spanish. And then I applied for maths and philosophy. The one thing I'd say about that is it was useful having done an essay subject.
Did you do any just at AS? Did you drop any of them? Or?
No, basically I started with too many ASs and then I didn't want to drop any, so that's how I ended up doing SIS.
Wow. Okay, I did maths, further maths, physics, French, and German, and French was an AS, when you could do the ASs. And I did maths at university. Can you share your interview experience at Oxford or Cambridge? So Sebastian, I'll ask you first.
Yeah, so I'm at Worcester and interviewed at Worcester at Oxford. I guess I'm trying to kind of narrow it down and not go on for ages. I'd say my interviews were very relaxed. I was sitting on a sofa for my interviews. It was almost just kind of like a conversation with the professors about maths. I guess one thing that was different to most other interviews is when I got here, so the first day I got here, they gave me a sheet of 6 questions. I had to attempt 2 and then bring them to the interview the next morning and then discuss those there. And then they asked me extra questions about it, which was quite good. And then I had one extra interview at Lady Margaret Hall, which, yeah, that one was more formal, kind of sitting at a table, them asking you proper questions. But it's not... I don't think it's anything to be nervous about, really. The professors are nice and they want you to do well. So
Great. Okay, Agnideepa?
So I don't know if there are any overseas applicants on this call. So I was interviewed overseas. I was interviewed in India, but I still had to fly out because India is quite large. But sometimes overseas applicants might still be called to interview at Cambridge. I had to do an admissions test at the interview. So that was a maths assessment, but kind of like the CSAT. And then I just had one interview because that's how the overseas application works. So I had one interview, and I believe some of my peers as well, they had only one interview. So even though they were from the UK. My interview experience wasn't really like Sebastian's. I wasn't given a bunch of problems to do beforehand. We got into the interview. But the interviewer can do anything they like. And this is a very important point that must be stressed. So the interviewer started by asking me just an icebreaker question about something in my personal statement. And then moved on to asking me something about an algorithm that they showed me on the spot. So they had some pieces of paper and they showed me how the algorithm worked. And then they asked me, so what is the time complexity of this algorithm? How many steps will it take on an input of this size? And then they asked me to write a bit of pseudocode. But that's only because they knew that I'd done computer science, that I was doing computer science. They won't ask you to write pseudocode if they know that you haven't done it. And lastly, they also asked me how I was planning to do in the competitive, non-compulsory competitive exams in India. So be prepared for curveballs. They might just ask you, how well do you think you're going to do at A level? So I'd say be prepared with an answer for those things.
Okay, brilliant. Thank you. Should you prepare for math? How should you prepare for math? Is it mainly just doing past papers? I think we've kind of covered that now in the talk at the end, where we kind of mentioned if you want to go back and listen, you can. What's the time difference between CTMUA 1 and 2? Like maybe 1 minute, like they are straight after each other. So I don't know why they kind of call paper 1 and paper 2, but they are kind of sat, at the same time. What super quick quiz is good for maths? I think, I think we've kind of covered these now, but it's just doing problem solving, and the Olympiads, the UKMTs, the other tests, the Enrich, that kind of thing will help you a lot with your maths. Does a Cambridge personal statement matter more due to there being no pre-offer test for maths, I guess? I would say probably not still, because you can talk about how good you are at maths, but they want to see it, and they're going to see it through your interview. So they interview people and they give more offers, but then with STEP, they kind of only take half the number of people that they make offers to. I don't know if anyone else wants to comment on that.
Yeah, I think I'm not. So do they not do the CTMUA for maths at Cambridge?
I don't know.
Yeah, that's interesting.
Yeah. So no, there's no pre-interview test for Cambridge. Some colleges, so for example at Trinity, as we've already heard, they do an at-interview test,
right,
and that's how they kind of get past that one to a certain extent. But I really don't think the personal statement makes a huge difference. And actually, it's really funny. In my last dinner or last whatever at in my third year, when we were all just about to leave, our tutors got all our personal statements and then read them out. It was the most hilarious thing ever. And I was probably the most geeky one in my college. Everyone thought all of the personal statements were mine. It's just like everyone's personal statements basically sounded the same. So really reading those, you couldn't even differentiate between the candidates at all. So I don't really think that's what they go on, I would say. I don't know if anyone else wants to add anything. Somebody says, how can we practice our problem solving for entrance exams specifically? Okay, I think everything we've discussed today, obviously the mastermind program. So if you are, if you want to improve your problem solving skills, discussing problems, we go through quite a lot of techniques. So that's obviously a really good method as well. Any other specific hints to give?
I'd just say of all the tests, the TMUA is closest to the ECHO in its new format. But yeah, it's still just maths.
I think I think one really underrated resource is actually YouTube. There's a lot of kind of really sort of brief videos of people solving various questions, and you can find probably anything on any topic. So I think that's quite useful.
I just say with that, if you're watching the video, you want to pause halfway through to actually do the problem yourself. You don't just want to watch someone solving the problem.
Right, yeah, absolutely. Do all
anyway, but you have to actually listen to them when they say pause.
Okay, then we got a question. Do all applicants take the test or only a selected group? If it's only a selected group, how are they selected? So yes, for CTMUA and MAT, everybody sits it. If you've applied, you sit it. For STEP, depending on which, let's just talk about STEP for Cambridge Maths. If you'll get made an offer in January, and if you get made an offer, it'll be dependent on your A-level grades and on your STEP grades. So at that point, they're kind of telling you need to sit the test. If you want to sit it otherwise, as Chris said, you can normally approach your examination officer and just say, yeah, I want to do it, but you may be charged for that. Whereas if it's part of your offer, it's likely that your school would offer that. And then what? Okay, as a GCSE student for now, should I be focused on broadening my knowledge of maths at A-level or beyond, or strengthening my grasp of programming, e.g. knowledge of programming languages and the such? I think that we should be focused on broadening, broadening knowledge is interesting. It's like, are you looking at things further or are you looking at things deeper? And I believe that doing like more problem solving with the current knowledge you have would help you more eventually than just looking at the next thing in the A-level syllabus. That's my opinion. Anyone else want to add to that?
I mean, I suppose it depends what subjects you're applying for. I would imagine you're applying for something related to computer science if you're talking about programming, in which case I'd say just both, to be honest. I think both are useful.
Okay, good. All right, last literally 2 or 3 questions. So would it be a bad idea to apply for maths at one uni and maths and philosophy at different uni? Chris?
No, not really. Your application needs to be strong for both. So you need to have, firstly, like maths and philosophy, you need to be as good at maths as you would be if you're applying for straight maths. It's not like an easier option. Secondly, you don't actually need to show any specific history of having studied philosophy at all. You should maybe explain when.
Well, you need to do reading. You need to have done reading.
Yeah, you should have done some reading around the subject, but you don't necessarily have to have studied it. And yeah, you should maybe explain that in your personal statement. Also, not all unis do both, so they'll understand if your application is different for the 2 unis.
Perfect. Isn't EPQ at all relevant for Oxbridge applications? I'm going to guess specifically for maths or computer science. I would say not particularly, like for your application. I would say no, but I don't know what other people think.
I mean, yeah, I think I agree. It's not, I'd say it probably isn't worth the amount of effort it is, but if you can fit that in anyway and it's no extra kind of problem to you, then I mean, it's definitely not going to hurt your application either. So yeah.
Good. Okay, I think that might be it. How do you structure your personal statement for different courses? Do you want to quickly talk about joint, well, maths and computer science? You applied for maths, didn't you, Sebastian? So you didn't do a joint personal statement.
Yes, no, I just did a maths personal statement. Yeah.
Okay, and then Chris, maybe you want to answer that one?
I can't really remember what I said when I applied now.
It was quite a while ago, so yeah. Well, I think probably we'll have to leave it there because it's already 10 o'clock. And somebody just says, can I say a massive thanks to all the panelists, especially Chris? He's so nice and very intelligent. I completely agree with that. Anyway, yeah, thank you all very much for joining. Huge thanks to Sebastian and Agni-Deepa for being here as part of our panel and giving real insight into what an Oxbridge application is like. And yeah, nothing else to add there. So thank you all very, very much and good luck. Take care. Bye.
Bye.
Bye.